Close your eyes for a moment and listen to the quiet around you. The refrigerator's low hum, a distant car, your own breath moving in and out like a tide. Nothing seems to be going anywhere. The room holds still. The floor is trustworthy beneath your feet, and if you lift a cup of tea, the surface barely quivers. Yet in this same calm, the ground is sweeping eastward as the planet turns. You, the chair, the window, the air itself are stowed aboard a world, rotating at roughly 1,000 miles an hour at the equator, gliding round the sun at about 67,000 miles an hour, all while the entire solar system sails through the Milky Way at nearly 500,000 miles an hour. Layer those motions together and it sounds impossible that your cup does not ripple, that your pulse does not race. But this is the first tenderness of the cosmos motion, so steady it feels like rest. We don't feel the Earth spin for the same reason you don't feel speed on a smooth train until it leans into a curve or brakes at a station. Our bodies are exquisitely tuned to notice changes in motion. Accelerations, jolts, the small betrayals of balance. In uniform motion there is no betrayal. The seat beneath you, the air around you and your own body are all moving together as if the world had gently taken your hand and said, "Come with me." No need to brace. Your inner ear, the tiny labyrinth that keeps you upright, listens for pushes and pulls. When the pushes vanish, the system relaxes into silence. Stillness then is not the absence of motion. It is motion shared so perfectly that nothing pushes against anything else. Think of an airplane pouring through the night at 500 miles an hour. Tea is poured, pages turn, a child sleeps cheek pressed to a window that is slicing the sky in two. The cabin feels like a room in the air, not because speed has disappeared, but because everything inside shares it equally. The Earth offers the same kindness. Rocks, oceans, cities and clouds keep the same smooth tempo, rotating as one the table. The spoon, the steam, rising from your cup, all locked in a long unbroken glide. To feel motion, something must disagree. Gravity must tug unevenly, the wind must shear the surface, must lurch. But tonight none of it does. Even so, the evidence of turning is everywhere for those who listen in slower measures. At dawn, shadows lean and then shrink. At night, the stars pass like a procession of lanterns circling a dark field. We learned long ago to measure this procession. The day is a unit of rotation, the year a count of orbits. Calendars are not decorations, they are the choreography notes for a dance we cannot step out of. Time for us is the name we give to the way the planet moves. There is another reason the world's speed feels like hush space is generous with emptiness. Air drags on, a cyclist waves, batter a swimmer, but above the atmosphere the vacuum is so close to perfect that nothing presses against our motion. The Earth can turn for billions of years without chafing against anything. The continents are passengers, not paddles. Astronauts understand this silence more directly. At 17,000 miles an hour orbiting the planet every 90 minutes, they float through a stillness so complete that a droplet of water will hold its shape like a tiny glass bead. Velocity without friction becomes a kind of quiet. And yet, if you ask physics to show you the turn not with poetry but with proof, it can do so with a simple instrument and a patient heart. In a hall or museum somewhere, a long wire descends from the ceiling, and at its end a weight glides to and fro, carving the same line through the air again and again. At first it seems no different from a clock's pendulum, but wait an hour or an afternoon. The line it cuts begins to rotate slowly and inexorably, as if the very floor beneath it had decided to drift. This is the Foucault pendulum, named for the French physicist, who let the Earth reveal itself without a single star for reference. The pendulum doesn't twist. The room does. Its plane of swing keeps faith with the distant universe, while the ground quietly turns beneath. A circle of small pegs around its base falls one after another like minutes tipping into hours. The first time you see it, the room feels a little different afterward, as if it had confessed a secret. We move through a nested set of rhythms. The planet wheels us into morning, the orbit carries us through seasons, the galaxy shoulders us along an arm of starlight. We don't feel the long swells, only the short choppy waves. A bus stops and our stomachs lean forward. A friend laughs and our ribs catch the echo. But the deep emotions, the ones that scaffold everything we do, are mercifully smooth. Children learn to walk without having to countersteer a spinning world. Birds navigate thermals rather than planetary drag. Our hearts keep time with biochemistry, not with the sweep of continents. The largest motions have made themselves gentle so that smaller lives can unfold. Even the numbers, those crisp little anchors we drop into the sea of wonder, are in their way consolations. A day is not exactly 24 hours, but just under a sidereal day because our planet turns once more than our sky appears to. Each evening arrives a few minutes different from the last. The difference is small, and yet the slow accumulation of small things is what sculpts oceans, mountains, forests, and understanding. We measure minutes because we live inside a motion we cannot feel. The clock is our translation device for a language the planet speaks with its body. If your senses were tuned to constant velocity the way they are to acceleration, this room would tilt and hum. Your tea would climb the cup's rim. Your breath would sway like kelp in a current. We'd be seasick on the shore. Instead, nature chose mercy. Our balance organs whisper only when something changes. And since the Earth's spin is nearly uniform, it becomes the most reliable lullaby in the world. Babies fall asleep in cars not because they love engines, but because steady motion teaches the body the shape of trust. There are moments when the disguise slips. Stand at the base of a high-latitude Foucault pendulum and watch noon creep around the compass. Feel the Coriolis tug when storm systems curl across satellite images, pinwheeling the way water appears to when it finds a drain. Notice how a tossed ball arcs in a long-range artillery table. Notice how a gyroscope resists being turned. None of these phenomena is loud, and that's precisely their lesson. The planet does not need to shout its turning. The proof is content to be patient. So tonight, let the paradox make you softer rather than restless. We live in a storm of perfect smoothness. Electrons rotate in their quantum ways, the Earth spins in its ancient rhythm, the Sun leads us around the galactic center, and the galaxy drifts with its neighbors through a space so wide that distances are measured in the speed of light multiplied by years. Our senses built for trees and footpaths cannot hold all that at once, and do not need to. It is enough to know that the stillness is earned, that we are cradled by agreements among moving things. If you return to the pendulum in your mind, you can see it now, in a quiet hall, its weight passing through. The same point again and again, gently drawing a flower of time on the floor. Around it, people murmur and go about their days, unaware that the room beneath them is turning under the curve of its swing. This is the truth the instrument keeps offering. Calm is not the absence of motion. Calm is motion in harmony. And once you really feel it, the world becomes easier to rest upon. The chair is not just a chair, it is a berth. The floor is not just the floor, it is a deck. The planet is not just a rock, it is a ship that sails so steadily you can sleep. Imagine peeling back time like layers of mist, each second thinner, hotter, stranger, until the universe itself is only a bright pulse. No galaxies, no light scattered through air, not even atoms yet. Only a sea of raw energy so dense that space and time are not partners, but one trembling fabric. Here in this first second after the Big Bang, everything that will ever move is waiting to learn how. If there was a moment when stillness and motion first diverged, this was it, the first turn. The early universe was not a silent explosion, but an unfolding and expansion that carried everything outward faster than light could chase it. We call this era inflation a brief and furious swelling, when space stretched 1 trillion times in the blink of an eye. During that expansion, microscopic fluctuations, tiny quantum jitters in the energy field, were pulled outward, magnified into the scaffolding of reality. Each fluctuation was like a ripple caught in a balloon, as it blew up frozen into larger and larger patterns. When astronomers study the faint afterglow of this event, the cosmic microwave background, they still see those ripples etched across the sky like fingerprints, pressed into cooled glass. At first glance, that light looks almost uniform, a soft bath of microwave warmth just a few degrees above, absolute zero, humming evenly in every direction. But high-precision satellites like NASA's WMAP and ESA's Planck have revealed it isn't quite perfect. Across its smooth surface run tiny variations in temperature 1 part in 100,000, so delicate that a butterfly's wing beats harder than the universe's first winds. And among those ripples, scientists noticed something peculiar, a subtle alignment, a long faint streak across the sky that seemed to suggest a preferred direction, a cosmic lean. They called it, half in jest and half in unease, the axis of evil. To some researchers, that alignment could be nothing but statistical chance, or a quirk of our perspective. But to others it hinted at something deeper, a whisper that the universe itself might once have rotated. If so, that spin would have left faint traces in the oldest light guiding how galaxies later twirled into spirals, perhaps even setting the arrow of time itself. If true, then everything that now turns from the swirl of hurricanes to the roll of planets could be the echo of a single ancient twist. But what could have set the universe spinning when it was smaller than an atom? The answer may lie in the quantum fields that filled space before matter existed. Even in apparent emptiness, those fields never sit still. They fluctuate, jitter create and destroy virtual particles in an endless dance. In that chaos, random asymmetries can appear tiny curls of motion that once stretched by inflation become the seeds of cosmic spin. It's as if the universe began with a sigh of imbalance, and that sigh never stopped expanding. The principle that governs this process is called conservation of angular momentum. It is one of nature's most loyal laws. Motion cannot come from nothing. It must be passed along, transformed, preserved. A figure skater spins faster when she draws in her arms. A collapsing star does the same when it shrinks to a neutron core. So too in those first fractions of a second when the newborn universe compressed and inflated, every small swirl was intensified. Cosmic skaters, pulling in their arms on a scale beyond comprehension. What began as quantum tremor became the rhythm of galaxies. Modern telescopes continue to listen for this rhythm. The Planck satellite in its final maps revealed delicate patterns in the polarization of ancient light, tiny swirls known as B-modes. These may be the fossil record of gravitational waves, ripples in space-time itself produced by inflation. Each wave would have carried a trace of rotation, a subtle twist in the geometry of reality. To detect them is to glimpse the first motion, the earliest choreography that matter ever performed. If we could somehow stand in that primal moment, though, there was no place to stand and no eyes to see, what would it look like? Perhaps nothing at all. Vision needs contrast, and there was none yet, only a luminous soup of energy rolling, curving, curling into itself. But we might have felt something if feeling could exist, then a push, a gentle torque in the fabric of being. That twist was not added later. It was woven in an inseparable property of space and time. The cosmos didn't learn to move. It was born mid-step. As the first particles condensed quarks, marrying into protons, electrons circling into atoms, each carried a fragment of that early angular momentum. Gravity gathered these atoms into clouds, the clouds into stars, the stars into galaxies, each preserving the initial spin the way fossils preserve bone structure. Billions of years later, we see its pattern everywhere. The spiral arms of galaxies, the whirlpool storms of gas giants, the rotation of planets, even the quantum spin of the particles that make up our bodies. The universe's original motion has never stopped. It simply changed scale. Astronomers still debate whether the whole cosmos rotates as one enormous entity, or whether the early twist has been smoothed into local eddies like currents in an ocean too vast to chart. But the evidence keeps whispering that rotation is not coincidence, it is identity. In 2020, astrophysicist Lior Shamir analysed hundreds of thousands of galaxies and found a tiny preference in their rotation direction, as though the sky itself were remembering a single ancient swirl. Perhaps what we call randomness is simply order too wide for our senses to resolve. To imagine the first turn is to imagine the birth of rhythm itself. Before there was time, there was change. Before change, there was imbalance. That imbalance became motion, and motion became music, the first note in a cosmic symphony that has been playing for nearly 14 billion years. Every orbit, every heartbeat, every second ticking on your watch is a faint harmony of that primeval beat. Take a slow breath. The air entering your lungs follows Earth's rotation, carved by the same angular momentum that set the galaxies spinning. You're breathing the consequence of the first turn, the moment when the universe stopped being still. That ancient rotation is not gone. It lives in the atoms of your hands, in the drift of clouds above you, in the swirl of the Milky Way across the night sky. Everything that moves is part of its continuation. And as we drift forward through this story, we are really drifting backward toward that first motion, the quiet spin that became all things. After that first cosmic shiver, the universe did not rest. It began to organize its motion to teach itself how to move with purpose. From the trembling plasma of its youth, gravity reached out like a hand gathering loose threads. Regions slightly denser than others drew in matter. Matter drew in more matter, and slowly, silently, the universe began to form patterns. Out of the chaos of expansion rotation found structure. Imagine vast clouds of hydrogen and helium, the only elements that existed then, spanning light years across. Gravity pressed on them gently at first, then insistently pulling them inward. As each cloud shrank, the conservation of angular momentum took hold, the same law that governs a spinning skater or a collapsing star. What began as a lazy swirl became a tightening spiral. Within these spinning clouds, pressure and temperature rose until hydrogen atoms fused and the first stars were born, blinding furnaces turning darkness into light. These newborn stars grouped together, drawn by mutual gravity, into families we now call galaxies. Every one of them inherited the motion of its birth cloud. The physics is simple, but the outcome is poetry. When a system contracts, it spins faster. When it expands, it slows. Nothing ever starts from rest, it merely transforms one kind of motion into another. The galaxies that emerged after a few 100 million years were not random shapes flung into the void. They were the universe's first choreography, graceful spirals, clumped ellipses, and irregular dances moving through the cosmic dark. Each galaxy carried an ancient memory of rotation, a fingerprint of the first twist imprinted into its very structure. As the cosmos aged, billions of these star systems filled the sky, and the great dance grew complex. Galaxies collided and merged, trading angular momentum like partners exchanging steps. Some spun faster, others slowed, spreading their arms of stars wider and thinner. Yet through it all, the law of conservation remained absolute. What was gained by one was lost by another, and the sum of motion stayed constant. The universe was not wasting energy. It was redistributing it, refining its rhythm. We can see this inheritance in action even now. Our own Milky Way turns once every 230 million years, a stately pirouette that carries the Sun and its planets through vast lanes of dust and gas. Our solar system formed within one of these lanes about 4.6 billion years ago, when another collapsing cloud condensed around a young star. As it spun faster, the leftover material flattened into a disk. From that disk came the planets, each keeping a portion of the cloud's rotation. Earth's daily spin, your sense of dawn and dusk, is the echo of that original swirl, a family heirloom billions of years old. But is all this motion truly random, or does it hide a deeper pattern? Astronomers have tried to answer that question by measuring the direction of galaxies' spins across the sky. At the Harvard-Smithsonian Center for Astrophysics, researchers catalogued tens of thousands of spiral galaxies, studying whether they turned clockwise or counterclockwise from our perspective. To their astonishment, a faint imbalance appeared. A few more spirals turned one way than the other. It was small, less than a couple of percent, but persistent even across opposite sides of the sky. If confirmed, it would mean that the universe itself retains a subtle preference, a handedness that might trace back to its earliest rotation. Other surveys have found similar hints. Using data from the Sloan Digital Sky Survey, astrophysicist Lior Shamir expanded the sample to hundreds of thousands of galaxies. His analysis suggested a large-scale pattern in spin direction, as though cosmic structures were following a hidden current. Not everyone agrees on the interpretation. Some argue it's an illusion of observation. But even skeptics admit the possibility is thrilling that the cosmos may have a built-in asymmetry, a whisper of direction left over from the first turn. If so, that preference isn't confined to galaxies. Rotation repeats itself in nature at every scale, from the swirl of storms to the spin of electrons. It's as if the universe learned a single rule and kept reapplying it over and over. Nothing moves in straight lines forever. Motion curves, folds, cycles, returns. When you see the spiral of a nautilus shell or the arms of a hurricane, you are seeing geometry written first among the stars. The beauty of these laws lies in their simplicity. Angular momentum cannot be created or destroyed. It only changes form. That single principle connects a child's spinning top to the orbit of Saturn, a dancer's pirouette to the revolutions of a galaxy cluster. When the top slows and wobbles, its energy leaks into the air as sound and friction. When galaxies merge, their momentum leaks into the cosmic background as gravitational waves. Every loss is balanced by a gain somewhere else, and the grand total remains unchanged. The universe is its own accountant, never misplacing a fraction of spin. Yet for all this precision, there is wonder in how delicately it all holds together. Too much angular momentum and galaxies would fling their stars into intergalactic darkness. Too little and everything would collapse into massive black holes. Somehow the cosmos found a middle tempo fast enough to create diversity, slow enough to sustain form. It learned balance not by planning, but by existing. The same way a river finds its path downhill, the universe found its rhythm. When you look at images from the James Webb or Hubble space telescopes, those glowing spirals and glowing filaments are not static pictures. They are frames captured from a motion so vast that our lifetimes cannot contain a single full rotation. The delicate arms of those galaxies are the frozen edges of whirlpools millions of light years wide. Light itself bends around their spinning centers, tracing arcs we call beauty, because our eyes evolved to recognize harmony when we see it. Perhaps that is why motion feels musical to us. The turning of the Earth becomes time, the orbit of the Moon becomes tides, the spin of galaxies becomes the cosmic rhythm that sets the pace for everything else. The physicist Brian Greene once described the universe as a symphony of strings, but long before string theory rotation already made the cosmos sing. Every atom, every planet, every galaxy is an instrument, and angular momentum is the beat they all keep in common. Take a breath and imagine that music filling the dark, the great universal metronome ticking, through 13.8 billion years of expansion. When you feel your pulse, you're keeping time with it. The same forces that turn galaxies are turning the blood in your veins, the atoms in your skin, the thoughts that circle in your mind. Motion is not decoration, it is definition. It is the cosmos's heartbeat, and you are one of its heartbeats too. 4.5 billion years ago, Earth was still young, a glowing sphere wrapped in storms of molten rock and gas spinning faster than it does today. Each sunrise came only 6 hours after the last. That furious rotation born from the same swirling debris that formed the planets would become the quiet architect of everything alive today. Because of that steady turn, the planet learned rhythm, day and night, heat, and cool light and dark, the first heartbeat of habitability. When the dust of creation finally settled and oceans began to form, Earth's spin had slowed to its familiar 24-hour pace. But that motion never stopped shaping life. Every morning that unrolls across the horizon, every evening that falls like a curtain exists because our planet rotates. As it turns, sunlight spreads like breath across the surface, warming oceans, stirring air, driving winds that cross continents. Without that rotation, half the world would roast in unbroken day while the other half froze in perpetual night. The equator would scorch, the poles would harden into endless ice. Only the line between light and darkness, a twilight ring of storms, might know movement. Life as we understand it would never have emerged. Earth's rotation is more than a clock, it's an engine. The steady spin stabilizes the magnetic field that shields the planet from the sun's relentless radiation. Deep within Earth's core, molten iron and nickel swirl in vast loops. That motion, amplified by rotation, generates an electric current, the dynamo that powers our magnetic field. This invisible armor deflects the solar wind, a stream of charged particles that would otherwise strip away our atmosphere the way the sun peeled the air from Mars. The northern and southern lights, those luminous curtains that dance across polar skies, are the visible proof of this protection. When solar particles brush against our magnetic shield, they're redirected along its lines, igniting the upper air with color. Those lights are not decoration. They're the planet defending itself in beauty. The rotation also commands the oceans. As Earth spins, the Coriolis effect bends the paths of moving air and water. Winds curve ocean currents, twist into spirals. This invisible steering gives birth to jet streams, hurricanes, and the great circulating systems that distribute heat around the globe. Without the Coriolis force, weather would stall, clouds would stagnate, and rainfall would collapse into chaos. Our climates, gentle or violent, are the choreography of rotation. The trade winds that carried explorers across the sea, the monsoons that feed half the world, the whisper of a breeze that cools your skin, all arise from a single planetary spin. Rotation reaches even into the smallest lives. Plants open their leaves at dawn and close them at dusk, guided by internal clocks synchronized to the Earth's turning. Animals migrate, mate, and sleep in cycles linked to the day's rotation. Even human biology hums to this rhythm. Our bodies carry circadian clocks, molecular gears that reset every 24 hours. In every cell, a quiet metronome ticks in harmony with the turning planet. If Earth's spin suddenly slowed or stopped, our hearts might keep beating, but our balance with the world would dissolve. The days would stretch into unbearable heat, the nights into killing cold. Air and water, freed from inertia, would surge eastward in colossal storms. The very skin of the planet would tear itself apart. Yet Earth's rotation is not perfectly steady. It drifts slow slightly over time. The moon's gravity pulls at the oceans, raising tides that drag faintly against the planet's spin. Each century the day lengthens by about 1.7 milliseconds. It is almost nothing, yet across billions of years it matters. When life first bloomed in the oceans, days lasted perhaps 20 hours. As rotation slowed, organisms evolved to match the changing tempo, adjusting their biochemistry to the lengthening daylight. Our planet's pace sets the tempo for evolution itself. To understand why rotation is so vital, we need only look to our neighbours. Mars spins once every 24 hours and 37 minutes, nearly Earth's rhythm, but its smaller size means its molten core cooled long ago. Without that churning interior, the Martian magnetic field collapsed. The solar wind stripped away its atmosphere, leaving behind a world of dust and silence. Venus, meanwhile, turns too slowly, one full rotation every 243 Earth days and in the wrong direction. Its slow spin lets sunlight linger too long. Heat builds carbon dioxide, traps it, and the planet becomes an oven hot enough to melt lead. Thick clouds of acid swirl through an atmosphere dense enough to crush steel. Mars spins too little inside. Venus spins too little outside. Between them, Earth's moderate pace is perfection, a golden rotation that keeps wind, water, and warmth in balance. The contrast is humbling. One planet's day too long, another's too short, and life cannot take hold. Ours, precisely poised, became a cradle. NASA scientists have simulated countless exoplanets, worlds spinning faster or slower, tilted more steeply or barely at all. The models show how delicate the balance is faster. Rotation yields violent winds and fleeting days. Slower turns produce extremes of temperature that erase oceans. Earth's 24-hour spin is a masterpiece of coincidence, a tempo gentle enough for complexity to thrive. And yet, even masterpieces evolve. The moon, born from a colossal collision in Earth's infancy, continues to tug on its parent, slowly pulling away as it drains our rotational energy. The tides that shape coastlines and guide migrations are part of this trader partnership between motion and memory. Every tide that rises carries away an infinitesimal fraction of the planet's spin, gifting it to the moon, which drifts an inch farther from us each year. The system remains in harmony because the exchange is slow, graceful, almost eternal. Balance preserved through giving. Without rotation, there would be no balance at all. No seasons cycling between growth and rest, no stable climate, no protective field to hold the air we breathe. Our planet's spin is the unseen hand turning the pages of life's story. It paints sunrise across the sea, then brushes darkness over deserts. It stirs the oceans so that coral reefs feed and clouds wander. Every pattern we call home, day and night, tide and time, is written by this simple, ceaseless motion. So take a moment even now to feel it, not through dizziness or drift, but through the constancy of what surrounds you. The air still here, the gravity firm, the light just right. You are balanced on a turning miracle, one that spins with such precision you forget it's happening. The same rotation that set the first winds to move across primeval seas still carries you through morning and into night. The earth has never stopped dancing, and because of that, you're here to breathe and to listen. Every world keeps time in its own way, but none so musically as Earth. Long before humans carved hours into stone or traced shadows on sundials, the planet itself was already a clock, its rotation, the hand that moves all others. Every dawn is a tick, every dusk a tock, and together they mark the rhythm by which oceans breathe, trees bloom, and hearts beat. Time on Earth is not an abstract invention. It's a living pulse carried in soil and sea, written in the spin of a planet that never truly rests. Inside every living thing, from plankton adrift in moonlit waves to the neurons that flare behind your closed eyes, there is a hidden metronome, an ancient biological rhythm tuned to the planet's rotation. Scientists call it the circadian cycle, from the Latin circa diem, about a day. In the cells of plants, proteins rise and fall like tides. In animals, hormones surge with the sun's climb and fade with its descent. The human body too listens to this subtle conductor. Temperature, blood pressure, alertness, even the release of melatonin for sleep all follow the turning of the world. We may wake by alarm clocks, but life itself wakes to Earth's rotation. When morning light first spills over the horizon, it strikes the retina and sends a signal to the brain's suprachiasmatic nucleus, the tiny patch of neurons that keeps the body's 24-hour time. That pulse resets the rhythm of every organ-syncing heartbeat to daylight. Evolution etched this pattern into us because survival demanded it. Plants that opened their leaves at the right hour absorbed more light. Animals that hunted at dawn or hid by dusk lived to pass on their genes. Over billions of years, rotation sculpted biology as surely as it carved rivers and mountains. The moon has been shaping that rhythm from the beginning. Its gravity tugs on Earth's oceans, pulling water toward it in two broad bulges tides that march endlessly around the planet. The rise and fall of tides are not just maritime poetry, they are the heartbeat of coastlines, the breath of estuaries where much of life began. Tiny organisms follow those cycles, hatching, feeding and spawning with each lunar pull. Even coral reefs anchored to stone release their eggs, on nights timed precisely to the moon's phase, as though the sea itself were an ancient clockmaker. The moon's drag also acts as a brake, imperceptibly slowing Earth's spin. Laser reflectors left by Apollo astronauts have confirmed it. The moon is drifting away by about 1.5 inches each year, lengthening our days by 1.7 milliseconds per century. The tempo changes almost invisibly, but the song continues a cosmic duet of planet and satellite dancer and partner, each adjusting to the other's steps. Every creature on Earth performs within that tempo. Birds migrate according to the shifting light. Trees know when to shed leaves not by cold alone but by the shortening day. Deep beneath the ocean, where sunlight never reaches fish, and crustaceans still keep a rhythm in tune with the planet's rotation, guided by internal chemical oscillations older than the continents. Even bacteria pulse with 24-hour cycles of growth and rest. Life, it seems, is a chorus singing in perfect time with the Earth's spin. The rotation also underlies our seasons. As the planet tilts 23.5 degrees on its axis, sunlight strikes different latitudes through the year. Spring unfurls when the northern hemisphere tilts toward the sun. Winter returns when it leans away. Without rotation combined with tilt, there would be no gentle transitions, no predictable growing seasons, no migratory paths. The length of day and the slant of light guide not only behavior but existence itself. Rotation is the metronome, orbit is the melody. Together they score the symphony of life. Scientists have begun to look beyond our world to see how this rhythm might play elsewhere. When NASA and EC simulate exoplanets, worlds orbiting other suns, they find that rotation speed can make the difference between a living world and a barren one. If a planet spins too slowly, one side bakes while the other freezes. Too fast and violent winds shred its atmosphere. But planets that turn in roughly the same rhythm as Earth, with a day long enough for heat to spread and short enough for cooling, show the best chances for temperate climates. Habitability, one researcher wrote, is the art of rotation. It's not just distance from a star that matters, it's the cadence of the world itself. Our planet's clock then is not mechanical but relational. The sun powers it, the moon adjusts it, and life listens to it. Even as the spin slows, ecosystems adapt. Fossil corals which grow in daily bands like tree rings show that hundreds of millions of years ago there were 420 days in a year, each day only 21 hours long. Ancient creatures lived faster lives, their metabolisms racing in step with the planet's quicker turn. As Earth aged and rotation eased, life lengthened its rhythm. Days grew longer, and so did possibilities: longer daylight for photosynthesis, cooler nights for rest, more stable cycles for evolution to work within. The slowing spin was not a decline, it was refinement. There's poetry in this, that the same tides that lap a shoreline today are carrying away fractions of the Earth's spin, gifting them to the moon. In return, the moon's gravity keeps our planet's axial tilt stable. Without that balance, Earth's orientation could wobble wildly, swinging climates from inferno to ice. Our seasons would collapse into chaos, our biosphere into crisis. The moon's gentle braking is also its gift of constancy, a slow dance that ensures the world keeps time without breaking step. Every second of your life depends on that balance. The 24-hour rhythm orchestrates not just biology but civilization itself. Our calendars, agriculture, sleep, work, art and love all unfold within its beat. When night falls and you grow tired, it isn't only fatigue, it's gravity and rotation chemistry and astronomy calling you to align with the planet's spin. Your heartbeat is not an independent rhythm, it quickens with daylight, slows with darkness. You're not simply on the Earth. You're of its motion, tuned to its invisible turning, like a string resonating with a note too deep to hear. The next time you close your eyes, think of that quiet rotation under your bed, that vast disk of rock and water, turning once more through space. Every breath, every tide, every rhythm of life is a moment in its revolution. The Earth turns and you turn with it. Each heartbeat is a small echo of the same motion that swings the oceans and folds the shadows of night across the world. The planet keeps time and all of life dances to it. Einstein once said that time and space are not separate things, they are threads in a single fabric woven so tightly that if you pull on one, the other moves. For most of human history, we imagine time as something constant, a universal river flowing evenly for everyone. Then Einstein looked closer and realized the river bends. Motion, gravity, and especially rotation can twist it, stretch it, slow it down. The universe, it turns out, doesn't just move through time, it sculpts it. Imagine space-time as a calm lake. When nothing moves, the surface is still perfectly smooth. But when a massive object spins, say a planet, a neutron star, or a black hole, it stirs the lake, creating tiny whirlpools. Those eddies are not water, but time itself, dragged along by the rotation. The faster or denser the spin, the deeper those vortices become. This phenomenon, known as frame dragging, was one of the most beautiful predictions of Einstein's general relativity. It tells us that the act of turning on a cosmic scale doesn't just move matter, it drags reality with it. Even here on Earth, this effect is real, though impossibly subtle. Our planet spins once every 24 hours, its mass enormous but not extreme. That rotation twists the fabric of space-time by about 1/10,000th of a degree each year, an angle so small it took one of the most precise experiments in history to confirm it. In 2004, NASA launched Gravity Probe B, a satellite carrying 4 ultra-pure quartz gyroscopes, each so perfect that if they were scaled up to the size of the Earth, their highest mountains would be less than 3 meters tall. The gyroscopes were set spinning in orbit, and for more than a year they pointed toward a single guide star in Pegasi, measuring how Earth's rotation warped the surrounding space-time. When the data came back, the numbers matched Einstein's equations exactly. The gyroscopes had slowly drifted in the direction predicted, not because of mechanical failure, but because time itself was being dragged around by the planet's spin. That bending is small on our world, but elsewhere it becomes staggering. Take a neutron star, the collapsed core of a massive sun so dense that a teaspoon of its matter would weigh 1 billion tons. In its death throes, the original star's rotation is conserved, and the smaller it shrinks, the faster it must spin, sometimes hundreds of times per second. These stars, called pulsars, emit beams of radiation that sweep through space like cosmic lighthouses. Their incredible rotation not only bends space and time, it also acts as one of the most precise clocks in the universe. Astronomers can predict the arrival of each pulse to within 1/millionth of a second, yet even that clock runs slower compared to those far from its gravity. In the warped space-time near a pulsar seconds, stretch light bends, and the flow of time itself becomes uneven. Push this idea further, and you reach one of the strangest creations of physics, the Kerr black hole. In 1963, mathematician Roy Kerr found a solution to Einstein's equations describing a rotating black hole, a place where gravity is so intense that nothing, not even light, can escape. But rotation adds a twist literally. Instead of a simple sphere, a spinning black hole drags space-time around it like a whirlpool twisting water. This swirling region outside the event horizon is called the ergosphere. Inside it, no object can remain still relative to distant space. Everything must rotate with the black hole. Time itself is forced into motion. If you could hover just outside that boundary and somehow survive the tidal forces, you'd see the universe beyond you speed up hours passing out there while only minutes slipped by for you. The faster the spin, the greater the distortion. Near some supermassive black holes, a single hour could equal years elsewhere. This is not imagination, it's measurement. In 2019, the Event Horizon Telescope captured the first image of a black hole's shadow in galaxy M87 and later of Sagittarius AE at the heart of the Milky Way. Those glowing rings we saw weren't the black holes themselves, but the light from gas orbiting them, at nearly the speed of light stretched and delayed by space-time curvature. What we are looking at when we see those rings is time made visible, light trapped, slowed, bent into an eternal spiral. Einstein's insight means that time is elastic, and rotation is one of the ways the universe stretches it. The stronger the spin, the deeper the slowdown. But this isn't confined to distant stars. The same principle plays out above our heads every day. The network of satellites we rely on for navigation, the global positioning system, must constantly correct for time dilation caused by both speed and gravity. Each GPS satellite circles Earth at roughly 14,000 kilometers per hour, where gravity is weaker and velocity higher than on the surface. The result is a tiny mismatch. Clocks in orbit tick about 38 microseconds, faster per day than identical ones on the ground. If uncorrected, that error would translate into a positional drift of several miles every day. So engineers bake Einstein's equations directly into the system. Every time your phone tells you where you are, it's quietly compensating for the bending of time around a spinning planet. Relativity isn't philosophy, it's GPS. Once you grasp this, even ordinary experience takes on a new wonder. The faster you move, the slower your time runs compared to those standing still. In a very small way, the people living at Earth's equator moving faster because of the planet's spin age infinitesimally slower than those at the poles. The difference is microscopic, yet it reminds us that time is not an external drumbeat. It's woven into motion, into mass, into the gravity that holds us. Rotation in this sense is not merely movement, but geometry in action. It doesn't just twist space, it gives time its texture. Every planet, star, and atom is engaged in that dance-bending space-time just enough to keep the cosmic balance. Even the light now reaching your eyes has been curved by countless rotations along its journey. The glow of a sunset, the shimmer of a star, all of it is time's slow spiral made visible. So the next time you check the time on your phone or watch a satellite drift across the night sky, remember what those seconds mean. They are not uniform ticks on an invisible clock. They are the product of a world that spins a star that pulls a universe that twists. Each moment is slightly different depending on where and how fast you move, and yet somehow it all holds together. Our clocks agree, our hearts keep pace, our days still feel even. That harmony is not accidental. It is the gentle gift of relativity motion balanced so perfectly that time, though bent, never breaks. Take a slow breath. You're sitting in a field of curved time, your seconds stretched and shaped by the turning Earth beneath you. The world's rotation carries you through the universe while quietly adjusting the rhythm of your life. Even now, as you read these words, you're gliding through a space-time subtly stirred by motion, proof that the planet's spin is not only the maker of days, but a sculptor of time itself. There are places in the universe where motion no longer means movement but surrender. Places where gravity grips space so fiercely that even light's swiftest of all messengers must bow and circle. These are spinning black holes, cosmic whirlpools born when massive stars collapse, carrying their rotation down into something smaller than imagination allows. Here spin doesn't just turn matter, it pulls on reality itself, dragging time into its orbit. Imagine approaching one. You are far from the event horizon, still in the realm where light travels freely, but the pull is already unmistakable. Around the black hole stretches a glowing disk of gas, the accretion disk circling at nearly the speed of light. The gas is so hot it shines in X-rays and ultraviolet, a furnace made visible by the James Webb Space Telescope and the Event Horizon Telescope. Through their combined eyes, astronomers can see what our own could never glimpse: a ring of fire around a shadow bright on one side, dim on the other. That asymmetry is not illusion, it's motion. The light from the side spinning toward us is blue shifted, intensified. The light from the other side is red shifted, stretched thin. Even photons obey the whirlpool's spin, their colours twisted by the geometry of time. As you draw closer, you cross into the ergosphere, the most surreal region in the universe. It lies just outside the event horizon, shaped not like a sphere but an oblate bubble, wider at the equator where the black hole's rotation is strongest. In this zone, space-time itself is dragged along, compelled to rotate with the black hole. Nothing here can remain still relative to the rest of the universe, not rocks, not light, not you. Even if you fire your engines at full power, you will still be carried eastward like a swimmer caught in a vast silent current. The closer you move toward the horizon, the stronger that drag becomes, until the concept of stationary loses meaning. Time behaves strangely here. If you could watch a clock strapped to your wrist as you descended, its seconds would seem normal to you, your heartbeat, your breath unchanged. But to an observer far away, your clock would slow your heartbeat, stretching your descent, freezing into slow motion. From the outside, you would appear suspended just above the horizon, your light dimming, your final moment never arriving. This is not illusion, but the direct result of the curvature of space-time. The deeper you fall, the more time itself stretches. At the event horizon, the stretching becomes infinite. Beyond it, cause and effect swap places. Inside that boundary, every possible path leads inward. Physicists describe this with precise mathematics, but words can only hint at the strangeness. Rotation here doesn't merely bend time, it tangles it. The black hole's spin twists the future into loops, making energy and motion interchangeable. In theory, you could exploit this twisting. In the 1970s, physicist Roger Penrose proposed that if a spacecraft entered the ergosphere and dropped a piece of itself spinning in the opposite direction, the escaping fragment could steal a fraction of the black hole's rotational energy. The process, called the Penrose mechanism, might one day power engines or explain the furious jets of matter that shoot from galactic cores, rivers of light traveling for millions of light years. The black hole, it turns out, is not only destruction, but potential a battery charge by the most violent rotation in existence. The event horizon. Telescope's image of Sagittarius A, galaxy's central black hole, gave this theory flesh. That faint trembling ring, captured through the combined effort of telescopes across the Earth, is a portrait of time in distress. The light we see circles the black hole multiple times before escaping, warped by the same frame-dragging Einstein predicted. In that ring, time is folding, light is stalling, and motion is turned into geometry. The James Webb Space Telescope deepens the picture. Its infrared gaze peers through dust and gas, revealing how these vortices feed, starve, and pulse. Each flare in its data is a heartbeat of time itself being consumed and reborn. When you imagine standing near that edge, you might feel a peculiar calm, the stillness that comes when every direction is forward. The swirl becomes silence, the light becomes slow, space and time have merged into one endless rotation. And then the haunting thought arrives. If spin can warp time so profoundly, could the opposite also be true? Could time, the deeper current, one day steer spin? Perhaps the universe has already answered. Everywhere we look, rotation and time are entangled. The faster something spins, the slower time moves within it. Yet the passage of time itself can alter. Spin stars lose angular momentum as they age, galaxies slow as they trade energy, even our planet gradually yields its rotation to the tug of the moon. Time sculpts motion, just as motion sculpts time. They are not rivals, but reflections, each shaping the other's flow. At the edge of the whirlpool, as light spirals and seconds elongate, the universe reveals its most intimate truth. Motion and time are one thing seen from two directions. What we call spin is time's visible form. What we call time is spin's invisible consequence. If the future could ever reach backward to guide the present, it would do so through rotation, through the slow, ceaseless turning of everything that exists. And so, the question lingers soft but enormous. If spin can bend time, could time itself someday steer spin? If the answer is yes, then perhaps every orbit, every revolution, every heartbeat is not only a trace of the past, but also an echo of what the future has already decided. The black hole turns, the galaxy turns, the planet turns, and beneath them all time turns too. There's a quiet irony in how we measure time. Every clock we've ever built is a mirror of motion. Pendulums swing gears, turn quartz. Crystals vibrate, atomic spins flip. We think of these as instruments of precision, but really they are small imitations of the cosmos itself. Every tick and tock is a faint echo of the universe's turning, a reminder that all keeping of time is in essence the keeping of motion. Consider the cesium atom, the heart of our most accurate clocks. Hidden inside it, electrons orbit and spin in strict predictable patterns. In 1967, scientists defined the second not by any human rhythm, neither heartbeat nor heartbeat's measure, but by nature's own metronome exactly. 9 to 192, 6 to 3 750 oscillations of a cesium atom's radiation between two energy states. This number isn't arbitrary, it's the Earth's rotation, the planet's heartbeat distilled to the subatomic scale. Every GPS signal, every internet timestamp, every synchronized heartbeat of the digital world depends on that steady atomic spin. But even this perfection needs correction. The Earth once thought, a flawless clock drifts ever so slightly. The moon's pull slows its rotation. Atmospheric tides, earthquakes, and melting ice redistribute its mass. These tiny shifts accumulate, and the planet's day lengthens by milliseconds over decades. To keep atomic time and planetary time in harmony, scientists add leap seconds, small pauses in the world's digital heartbeat. In those seconds, satellites, banks, and servers across the globe hold their breath, waiting for Earth to catch up with its own shadow. The gesture is humble, almost tender. The machines we built to outpace the world must occasionally slow down to stay in step with it. Even at our most advanced, we cannot escape the need to align with motion. GPS satellites circling 20,000 kilometers above us keep time using atomic clocks that must be continuously corrected for Einstein's relativity. Up there, farther from the pull of Earth's gravity, time runs faster about 45 microseconds each day. Meanwhile, their speed through orbit slows their clocks by about 7 microseconds per day. Engineers adjust for both effects so that the satellite's time matches ours on the surface. Without that correction, your phone would misplace you by several miles within hours. The synchronization of machines' orbit and relativity is a daily symphony of motion. Obeying motion, a proof that time itself is elastic, yet beautifully coherent. Zoom outward, and the same principle holds. The Moon's orbit stabilizes Earth's spin. Jupiter's mass sculpts the pairs of asteroids. The Sun's rotation governs the solar wind. Zoom inward, and you find electrons spinning around nuclei defining chemistry and color. From the largest galaxies to the smallest particles, everything keeps its rhythm by moving. There is no unmoving reference point, no absolute stillness to measure against. The universe runs not on an external power, but on the perfection of its own balance. For centuries, humanity sought the hidden hand behind all this turning. Ancient philosophers imagined celestial spheres driven by divine engines. Newton spoke of a cosmic clockmaker winding the universe and letting it tick. But Einstein and the generations who followed revealed something subtler. The clock doesn't need winding. Once motion exists, it sustains itself. Energy converts, exchanges, transforms, but it never vanishes. The universe doesn't run down. It evolves through the conservation of motion, the ceaseless recycling of angular momentum. Every orbit, every spin, every wave is a negotiation between inertia and gravity, between the desire to continue and the urge to fall. Yet no force stands outside it pressing start. The beauty of motion is that it contains its own permission. No conductor waves the baton. The music plays itself. You can see this in the sky tonight. The stars you think are still are actually racing through the galaxy, each tracing its curve around the Milky Way's center. The galaxy itself drifts toward Andromeda, both bound in a slow, spiraling embrace that will take billions of years to complete. Nothing is stationary. Even the space between galaxies, the cosmic void, is stretching, expanding, carrying everything within it. Time flows because motion does, and motion flows because time does. They are not partners, but the same phenomenon seen from two directions. When you look at a clock, you're not witnessing time passing. You're watching motion unfold. The pendulum swings because gravity trades height for speed. The quartz crystal vibrates because energy bounces between tension and release. The cesium atom spins because the universe's laws demand symmetry and change. The hands move because the planet moves. The numbers change because we do. And still we ask the question, who controls the spin? Who keeps it all from collapsing or flying apart? The answer quietly is no one. The universe requires no outside force to keep turning. The rules of physics, the conservation of energy, the balance of forces, the geometry of space-time are not imposed from without. They are the nature of existence itself. Motion doesn't need management. It persists because persistence is what it is. If you've ever watched a spinning top, you know how for a moment it seems alive, balancing perfectly, humming softly, graceful until friction and gravity slowly bring it to rest. The universe is like that top, but with no friction to slow it, no table to stop it. It spins within itself, exchanging motion between stars and particles endlessly. The dance continues not because someone winds it, but because movement and being are the same thing. Perhaps that's the quiet lesson hiding inside all our clocks, all our orbits, all our efforts to measure and control. We're not outside the motion taking notes. We are part of it. The beating of your heart, the electrons whispering through your neurons, the Earth's rotation beneath your feet, all are moments in the same eternal spin. So when you glance at your watch, when you check the second scroll on your phone, remember what it really measures. It's not counting down. It's keeping faith with the turning of the world, the revolution of atoms, the dance of galaxies. It's the hum of a self-sustaining universe that never needed a hand to push it. It turns because turning is what reality does, and in that realization lies a strange peace. There is no grand clockmaker, no cosmic supervisor, only motion perfect in its self-continuing grace. The universe spins, the atoms spin, and you spin with them. Time doesn't move forward, it moves around, and somehow everything stays in step. Everywhere you look, from the faintest particle to the grandest galaxy, the universe obeys one quiet promise: what spins must keep spinning. This is the law of angular momentum conservation. the pack that binds all motion together. It says that in a closed system, rotation can change its form but never its total measure. The child's spinning top, the orbit of moons, the swirl of hurricanes, the rotation of galaxies, all are different verses of the same law. Angular momentum is the universe's memory of motion, and it never forgets. In atoms, that memory is intimate. Electrons orbit nuclei in quantum shells, each with a distinct angular momentum. Their spin, an intrinsic kind of rotation not around space, but within it, gives rise to magnetism. Without that spin, there would be no chemistry as we know it. Iron could not align into magnets. Molecules could not form the delicate bonds that make DNA twist and proteins fold. At the smallest scales, angular momentum is the difference between inert matter and living matter, the rule that turns stillness into possibility. At stellar scales, it becomes orchestral. Stars are born from collapsing clouds of gas conserving their angular momentum as they shrink. The faster they spin, the more intricate their internal dynamics. Our Sun is a perfect example of this grace. It doesn't rotate as a solid body, but in layers its equator spinning, once every 25 days, its poles taking about 35. This differential rotation churns plasma deep within, generating tangled magnetic fields that burst to the surface as sunspots and solar flares. Every aurora you've ever seen, the curtains of light swaying above polar skies, is a distant echo of that rotation, translated through 150 million kilometers of space. The sun's spin writes its signature across the solar system, but the same principle extends much farther. Galaxies too carry rotational energy that defines their structure. The European Space Agency's Gaia mission has mapped the precise positions and motions of more than 1 billion stars in the Milky Way, revealing patterns invisible before wave streams and slow currents of rotation that ripple through our galactic disk. These are not random drifts, they are the choreography of angular momentum conserved across cosmic time. When galaxies collide, their spins entwine, reshaping each other, but never losing the total sum of motion. Angular momentum doesn't die. It migrates, dissolving from one form to another. If we could see motion itself rather than matter, the universe would appear as a vast lattice of spinning energy. Particles rotate, stars rotate, galaxies rotate, and space around them curves accordingly. According to Einstein's field equations, angular momentum is not a trivial feature, it actively molds space-time. A rotating mass drags the geometry of the universe around it, twisting time and space together. It's this union that produces frame dragging near Earth and the immense warping near black holes. Spin and space-time are not separate actors, they are mutual authors of the same story. Motion bends time, curved time sustains motion. Physicists sometimes describe this relationship with a quiet reverence. The energy that shapes curvature and the curvature that governs motion feed each other in a closed loop, perfectly balanced, endlessly reciprocal. It's a system without waste or remainder, an engine that never requires fuel. Energy and motion keep the cosmos in equilibrium, a balance so profound that even entropy, the great enemy of order, must respect it. Disorder can grow, heat can dissipate, but the total angular momentum persists, unchanged, the backbone of all becoming. This balance is visible in subtler ways too. When a figure skater draws in her arms, her spin quickens. She doesn't gain energy from nowhere. She converts potential to kinetic, redistributing what she already possesses. Stars and galaxies perform the same act on unimaginable scales. A collapsing protostar tightens and accelerates. A dying star stripped of mass spins faster as it becomes a neutron star or a pulsar. Each transformation obeys the same simple rule: if the moment of inertia shrinks, angular velocity must increase. It's as if the universe whispers through every form, remember how you turned. Don't stop. Even magnetism itself, the invisible architecture holding the cosmos together, owes its existence to rotation. The Earth's magnetic field, the sun's flares, the swirling jets of quasars all arise from the motion of charged particles. Rotation organizes chaos into coherence. Without it, energy would diffuse evenly, and the universe would be a silent fog. With it, energy circulates, condenses, evolves. Motion doesn't merely conserve itself. It creates structure from the atom's spin to the galaxy's spiral arms. When Einstein wrote his equations, he was describing more than gravity. He was uncovering a hidden symmetry, that the geometry of the universe responds to energy momentum and spin the way water responds to stones dropped into it. The curvature of space-time is the ripple pattern of existence itself, and angular momentum is its rhythm. time in this view is not a linear arrow but a rotation, a turning of the universe upon its own laws. This perspective reframes everything we know about stability. The stars above you do not hang in place because they are fixed. They endure because they are in motion, because angular momentum preserves them against collapse. The same is true for your planet, your atoms, even your heartbeat. Life is a local triumph of balance between energy's constant dispersal and motion's constant conservation. Every breath is a small echo of that balance energy exchange momentum sustained. If you could listen closely enough, perhaps you'd hear it a universal hum, the resonance of matter and motion keeping each other alive. It's the same tone that hums in an atom's spin, a planet's orbit, a galaxy's rotation. The universe doesn't need a clock to measure time. Time is the rhythm of motion maintaining itself. And in that sense, Einstein's equations were not only about gravity, they were poetry about endurance. So tonight, as you stand beneath the stars, remember that the quiet arcs above you are not still. Each is turning, each is contributing its small share to the conservation of the whole. Time itself may well be written in motion, and motion in time, a sentence the universe has been repeating since its first breath, each rotation, another word in the same endless story. In the beginning there was balance, perfect, featureless, and silent. Every direction was the same, every force indistinguishable from the next. It was a universe without contrast, without shape, without motion, and in that perfection nothing could happen. Then, in less than a heartbeat, after the Big Bang, perfection broke. Physicists call this symmetry breaking, and in that shattering lay the origin of everything, of gravity and light, of matter, and time, of the faint asymmetry that allowed a universe of stars instead of a void of radiation. Perfection, it turns out, was too fragile to endure, and that failure became the seed of creation. In the earliest fraction of a second, the universe was a single unified field, a furnace of energy where the four fundamental forces were one. As it expanded and cooled, this unity fractured. Gravity peeled away first, its strength weakening as the cosmos ballooned outward. Then came the strong nuclear force, then the weak force, and finally electromagnetism. Each separation left behind a faint imbalance, a crack in the mirror, and through those cracks motion appeared. Symmetry had given way to direction. Timelessness gave way to time. Imagine a perfectly balanced pencil standing upright. In theory, it could remain that way forever. But the smallest nudge, a breath of air, a vibration, will make it fall, and once it chooses a direction, that direction defines everything afterward. The universe fell in the same way. It chose a direction for time, for spin, for matter over antimatter. And that choice once made became irreversible. When the Higgs field emerged about a trillionth of a second after the Big Bang, it froze one of those imbalances into permanence. Space filled with an invisible field like a sea of molasses that gave particles their mass. Before this, everything moved at the speed of light. After it, particles slowed down, gathered substance, and began to form atoms. The Higgs field was the first great act of slowing down the universe's way of converting energy into matter. Without that gentle drag, there would be no atoms, no chemistry, no us. But even mass alone wasn't enough. For matter to dominate, it had to survive its mirror twin antimatter. When the universe was young, it created both in nearly perfect balance. Every proton had an antiproton, every electron an anti-electron. When they met, they annihilated, vanishing in flashes of light. According to the simplest equations, this annihilation should have been total, leaving behind nothing but energy. And yet here we are, evidence that something somehow tipped the scales. The tipping point was small, one extra particle of matter for every billion pairs that destroyed each other. That 1 billionth leftover became all the matter in the universe. Galaxies, planets, oceans, life, everything built from a microscopic asymmetry called baryon asymmetry. For decades, scientists wondered what caused it. Then in 1964, two physicists, James Cronin and Val Fitch, working at Brookhaven National Laboratory, made a startling discovery. While studying decays of subatomic particles called kaons, they found that the laws of physics treat matter and antimatter ever so slightly differently. This violation of symmetry, known as CP violation, proved that nature has a preference. The universe itself, down to its tiniest building blocks, is biased toward existence. It is an astonishing thought that every mountain, every heartbeat, every beam of starlight exists because the universe once made a mistake. Symmetry. Breaking is not a flaw, it's the most creative act in cosmic history. When the Higgs field acquired its non-zero value, The symmetry between light and matter was shattered, and from that fracture came diversity: electrons, quarks, protons, and eventually atoms. The European Space Agency's Planck satellite mapped the faint microwave afterglow of the Big Bang and found tiny fluctuations 1 part in 100,000 ripples in temperature that mark where that early perfection broke. Those ripples grew into galaxies. Without them, the cosmos would have remained smooth, structureless, and lifeless. Even time itself owes its arrow to asymmetry. If entropy, the tendency toward disorder, had been perfectly balanced, time could flow forward or backward equally. But the universe began in a state of extraordinarily low entropy, a fragile order that could only decay one way. The fall from order to disorder defines the flow of time. In every moment that passes, in every star that burns and cools, we're still sliding down the slope carved by that first imperfection. The echoes of this imbalance are everywhere. Neutrinos, ghost-like particles that stream through your body, by the trillions each second, all spin left-handedly. Molecules of life, DNA, amino acids, sugars also share this left-right bias. Even on biological scales, the universe's preference persists, as if life itself remembers which way the first symmetry broke. Modern cosmology sees this not as an accident but as a signature. The Planck and WMAP satellites detected subtle directional alignments in the cosmic microwave background, hints that the universe may retain a faint global spin, a memory of its first broken balance. Some call this the axis of evil, though its name is misleading. It's less malice than memory, a whisper from when everything first began to turn. Without imperfection, there would be no structure, no time, no stars. Perfect symmetry means no difference, and difference is the essence of existence. Perfection is sterile. Imperfection creates contrast, and contrast allows creation. As theoretical physicist Murray Gell-Mann once said, if the world were perfectly symmetrical, there would be nothing. So the next time you see the unevenness of life, the tilt of the planet's axis that makes seasons, the imbalance between light and shadow at dawn, remember that everything you love depends on imperfection. The universe's first act wasn't to create order, but to break it. Take a slow breath. The air entering your lungs carries atoms born from that ancient imbalance matter that refuse to cancel out. The carbon in your blood, the oxygen in your brain, all exist because the cosmos once leaned slightly towards something rather than nothing. In that tiny tilt, creation found its voice, and from that crack in symmetry came everything that moves, breathes, and dreams. Perfection didn't last, but in breaking it made beauty possible. Perfection is beautiful but sterile. Only when it cracks does creation begin. Every pattern we know, from the swirl of galaxies to the spiral of DNA, is born of imbalance. And the deeper scientists look, the more they find that imperfection isn't the flaw of the universe. It's the reason it exists at all. Take the neutrino, that ghostly particle slipping through your body by the trillions each second. It barely interacts with anything, yet it carries one of the universe's most profound secrets. Every neutrino spins left-handed. Its mirror version, the right-handed neutrino, has never been seen. This one-sidedness violates what was once believed to be an inviolable rule of symmetry. It means nature has a preference, a direction built into its core. That preference didn't vanish as the universe cooled and stars ignited. It deepened. At the molecular level, the same asymmetry reappears in the very architecture of life. DNA always coils to the right, while the amino acids that build every protein in your body twist to the left. Chemists call this chirality handedness. You can imagine it like gloves left and right, shapes that look identical until you try to fit one on the other. In non-living chemistry, both forms appear in equal amounts. But life on Earth chose a side long ago, and it has never switched back. Why, one answer comes from light, the universe's first messenger. In the ancient star-forming clouds, where organic molecules began to form light from newborn stars, was not evenly polarized. Passing through cosmic magnetic fields, it became circularly polarized, twisting one way more strongly than the other. NASA's Astrobiology Institute has shown that this asymmetric light could destroy one type of amino acid slightly faster than its mirror twin. Over eons, that tiny bias may have tipped the balance of prebiotic chemistry. By the time Earth formed, the recipe for life already carried the universe's original preference, written in the spin of starlight. The Rosetta mission to Comet 67P confirmed this story in 2014, when it detected complex organic molecules showing hints of chiral imbalance. They weren't perfectly symmetrical either. The seeds of life, long before there were oceans or cells, we're already leaning toward one side. Even meteorites like the famous Murchison fall in Australia contain a surplus of left-handed amino acids. It's as though the cosmos practiced making life long before Earth took its first breath. This pattern of asymmetry repeats across every scale of reality. Look up and you'll find it painted in the faintest light of all the cosmic microwave background, the ancient afterglow of the Big Bang. At first glance, it's almost uniform, a bath of radiation spread evenly across the sky. But the Planck satellite's maps show subtle ripples, tiny temperature differences, only a few millionths of a degree apart. Those minuscule imperfections are the fingerprints of creation itself. Where the radiation was a little denser, gravity took hold, gathering matter into clumps that became galaxies. Where it was thinner, space expanded into the voids between them. Without those ripples, those cosmic freckles, the universe would have remained a smooth, dark fog. We owe every star, every planet, every living thing to those infinitesimal deviations from perfection. And now, with the newest instruments, scientists are tracing those ripples in soundless waves. The BSEP-2 and Planck missions have searched for subtle curls in the polarization of the microwave background, what physicists call B-modes. These swirling patterns could be the fossils of gravitational waves, ripples in spacetime born during the universe's first second. If confirmed, they would be direct evidence that the cosmos began in motion, twisting and stretching, even before atoms existed. It's astonishing that such vast beauty spiral galaxies, auroras, the pulse of your own heart, can all trace their ancestry to something so small, so delicate, a slightly uneven start. Imperfection built structure. Structure built complexity. Complexity built consciousness. The same imbalance that makes stars form also lets time flow. Entropy. The arrow of time is itself an asymmetry, a direction that favors dispersal over return. You can stir milk into coffee but never unstir it. That irreversible tilt in probability is the quiet echo of the first broken symmetry. It's why you age, why stars burn out, why history has a direction at all. And yet this asymmetry is not chaos. It's precise, measured, and astonishingly consistent. The differences are small enough to allow order but large enough to prevent stillness. Too much symmetry and the universe would be frozen. Too little, and it would be chaos. Instead, it lives in the narrow space between where balance trembles, where creation thrives. That's the elegance of imperfection. It is not random. It is tuned. Every deviation from symmetry has meaning. The left-handed neutrino, the right-handed DNA, the faint cosmic ripples, each a note in the same cosmic chord. Without them, existence would be mathematically flawless and utterly empty. When you look in a mirror, you see your reflection reversed. But imagine if the universe had no preference, if left and right were truly equal. Then the reflection would not be opposite, it would be identical. Nothing could differentiate itself from its image. No time, no evolution, no life. The mirror would be reality itself, and reality would be still. So we live because the universe is not perfectly fair. Because it tilted, however, slightly in favor of motion, matter, and memory. Because symmetry cracked, and through that fracture flowed everything we call beautiful. Take a moment, close your eyes, and breathe. Inside you, the molecules twist in the same direction as the galaxies that gave them birth. Every atom in your body remembers that first imperfection, the choice the cosmos made between nothing and something. We are the living evidence that imbalance can be exquisite. The stars burn, the galaxies spin, and we exist not in spite of imperfection, but because of it. There's a paradox hidden in every night sky. You look up and the galaxies seem calm. Great pinwheels of stars turning slowly through eternity. Yet the truth is far stranger. Those galaxies are spinning too fast to exist. By every law of physics, they should have flown apart long ago. Their stars racing at hundreds of kilometers per second should have scattered like sparks from a wheel. But they haven't. Something unseen is holding them together, an invisible hand strong enough to bind the cosmos yet utterly silent. This is the story of that hand, the story of dark matter. It began quietly in the 1930s with a Swiss astrophysicist named Fritz Zwicky. At Mount Wilson Observatory, he studied a distant swarm of galaxies called the Coma Cluster. When he measured how fast its galaxies were moving, he found they were speeding far too quickly to be held together by the gravity of the visible stars alone. To explain this, Zwicky proposed something radical. There must be a hidden mass, dunkel materie, dark matter outweighing everything we can see. His peers dismissed it as eccentric speculation. but the universe would eventually prove him right. 4 decades later, in the 1970s, an astronomer named Vera Rubin climbed the lonely steps of Kitt Peak Observatory in Arizona and pointed her telescope toward the Andromeda Galaxy. What she found would change our understanding of the cosmos forever. Rubin measured the speeds of stars orbiting Andromeda's center. According to Newtonian physics, stars near the core should move quickly, while those farther out should slow down, just as planets near the Sun orbit faster than distant Neptune. But her data told a different story. The stars on the edge of the galaxy were moving just as fast as those near the center. It was impossible unless most of the galaxy's mass was invisible. Night after night, Rubin mapped dozens of galaxies. Each one repeated the same refrain: flat rotation curves, constant speed from core to rim. It was as if the visible stars floated within vast unseen spheres of gravity. The idea once dismissed by Zwicky was no longer fantasy, it was necessity. Today we know that these halos of dark matter form the hidden architecture of the universe. Every galaxy, including our Milky Way, swims inside one. They are enormous, extending hundreds of thousands of light years beyond the visible disks, containing 5 times more mass than all the stars and gas combined. Without them, galaxies would simply disintegrate. But what is dark matter made of, we still don't know. It neither emits nor reflects light. It passes through ordinary matter without friction, invisible to telescopes yet undeniably present through its gravity. NASA's Chandra X-ray Observatory and the Hubble Space Telescope provided one of the most compelling proofs in 2006, the Bullet Cluster. 2 galaxy clusters had collided head-on, tearing through each other in a slow-motion cosmic crash. Chandra's X-rays showed where the hot gas, the ordinary matter, was left behind in the collision. But when scientists mapped the gravitational field through a technique called gravitational lensing, the bending of light from background galaxies, they found the mass wasn't where the gas was. It had passed through unaffected, like ghosts through fog. The invisible mass was separate, dominant and real. Dark matter's gravity warps the fabric of space-time itself, bending the light of distant galaxies into arcs and halos. Through this lensing effect, astronomers can trace the distribution of dark matter across billions of light years, even if they can't see a single particle of it. The results are astonishing. Cosmic maps reveal an immense web-like structure, filaments and nodes of invisible mass threading the universe. At each intersection, ordinary matter gathers, birthing galaxies like dew on a spider's web. The European Space Agency's Euclid mission, launched in 2023, now charts this cosmic skeleton in unprecedented detail. Its instruments measure the faint distortions in starlight caused by dark matter's gravity, building a 3-dimensional map of the hidden universe. The data so far suggest that dark matter halos formed first, pulling gas and dust into their gravitational wells. They are the scaffolds upon which galaxies assembled the invisible blueprints of creation. In this way, dark matter became the universe's quiet engineer, shaping everything without ever being seen. The Hubble Space Telescope's deep field images, filled with thousands of distant galaxies, are not just pictures of light. They are portraits of dark matter's handiwork. Every glowing spiral is balanced atop a vast halo of shadow. Even now, deep beneath mountains and in Arctic laboratories, scientists are searching for dark matter's true identity. Some imagine it as a sea of exotic particles, WIMPs, weakly interacting. Massive particles or lighter entities called axions. Others suspect it may be a new manifestation of gravity itself, a flaw in our understanding of the fundamental laws. The experiments, Xenon in Italy, Lux, Zeppelin in South Dakota, Super CDMS in Canada, wait patiently in the dark for the faintest whisper of a collision between ordinary and invisible matter. But whether particle or principle, one truth remains: without this unseen substance, the universe could not hold itself together. The stars would fly apart, the galaxies dissolve, the cosmic web unravel. Dark matter is the quiet architecture behind everything, the unseen symmetry that survived after the visible one broke. It doesn't shine, it doesn't speak, but it holds the galaxies in its hands. We orbit inside it every moment of our lives, wrapped in a halo of gravity we can neither feel nor see. When you look up tonight, know that every star you admire is suspended by something that does not glow a shadow vast enough to cradle light itself. The universe spins because something invisible steadies it. And in that unseen balance lies a strange comfort that even in the emptiness there is structure, even in the dark there is design. For centuries we believed the universe was made of what we could see: stars, planets, gas and light. But now we know that everything luminous, everything visible, is only a fraction of the truth. The rest, the majority, is shadow. To glimpse that shadow, we had to learn to see without eyes. Gravitational lensing became our first true way of doing so, a trick of nature that lets gravity itself act as a telescope. When light from a distant galaxy passes near a massive cluster, space-time curves, and the light bends around it like glass. To us, the galaxy appears stretched, doubled, or ringed into arcs of ghostly brilliance. Those distortions are more than beautiful. They are measurements. By studying how light bends, astronomers can map where mass truly lies, even when it's invisible. The most haunting proof came from a cosmic collision 6 billion light-years away, the Bullet Cluster. In this galactic train wreck, two clusters of galaxies pass through one another at thousands of kilometers per second. The ordinary matter, the hot gas, crashed and slowed, glowing in X-rays captured by NASA's Chandra Observatory. But when scientists measured the gravitational pull through lensing, they found the mass had kept going, sailing past the luminous wreckage like a ghost. The heavy heart of the system wasn't the visible matter at all, it was dark matter, continuing forward, invisible, but undeniable. That image, the pink X-ray gas offset from the blue gravitational map, became one of the most profound photographs in the history of science. It was the first time we saw the unseen not by light, but by the way it bent the light of others. Humanity had in a sense photographed a shadow. Since then, the effort to chart this hidden architecture has only deepened. The European Space Agency's Euclid mission now drifts through space, capturing the faint distortions of billions of galaxies across cosmic time. Each pixel of its camera measures a tiny ripple in space-time, a clue to where dark matter hides. Over the next decade, Euclid will create a three-dimensional atlas of the cosmic web, showing how invisible mass threads through everything we see. NASA's upcoming Nancy Grace Roman Space Telescope will join the search, using its immense field of view to trace how dark matter has sculpted the universe's expansion. Its surveys will look billions of years into the past, revealing how the unseen scaffolding guided galaxies into the shapes we know today. And even now, the James Webb Space Telescope peers into that distant infancy, capturing galaxies so young they formed when the universe was less than 400 million years old. Some already show rotation proof that the hidden hand of dark matter was at work from the beginning, shaping the first spirals of creation. If we could see dark matter directly, the night sky would look utterly transformed. Between every cluster of stars would stretch filaments of soft transparent structure, cosmic veins through which gravity flows. The galaxies we know would hang like lanterns strung along invisible threads, each one a bright knot in a web billions of light-years across. In that sense, the search for dark matter isn't only scientific, it's profoundly human. We are creatures built to seek what hides beneath the surface. We map the unseen not just in the heavens but in ourselves. Emotions, unspoken memories, half-forgotten forces we feel but cannot name. Just as galaxies are bound by invisible halos, our lives are held together by unseen gravities. Love, fear, hope, belief. The cosmos has its dark framework, and so do we. Astronomers call dark matter the cosmic scaffold, but perhaps it is better imagined as the universe's skeleton unseen, yet giving everything its shape. Without bones, the body collapses. Without dark matter, the cosmos would dissolve into formless light. What holds the galaxies together holds us too, the idea that what matters most is rarely visible. The modern telescopes in their silent vigil reflect that truth. Euclid, Roman and Webb drift through the void, searching not for brightness but for distortion, looking for the way light bends under something unseen. Their images are maps not of light but of influence, and each discovery tells us something about ourselves, that we too are defined not only by what shines within us, but by the shadows that give that light its shape. In every gravitational arc, every faint lensing curve across the sky, we glimpse the universe's invisible geometry, and perhaps a reflection of our own. The darkness isn't absence, it's structure. The unseen isn't emptiness, it's foundation. So as you watch the stars tonight, remember what holds them in place is something you cannot see. And maybe what holds you together is the same. The deeper we peer into the cosmos, the stranger its proportions become. Everything we can see, the blazing stars, the drifting galaxies, the clouds of interstellar dust, makes up barely 5% of reality. The rest is divided between two vast opposing mysteries: dark matter, which pulls, and dark energy, which pushes. Together they choreograph the grandest dance in existence, the slow, graceful struggle between gravity and expansion, between binding and release. Dark matter is the invisible skeleton, the quiet architect holding galaxies together. Dark energy is the opposite, a hidden pressure stretching the fabric of the universe apart. One builds, the other unravels. One holds the stars close, the other sends them drifting into infinite distance. For billions of years, they've been locked in a cosmic waltz, each shaping the destiny of everything that moves. In the first few billion years after the Big Bang, dark matter led the rhythm. Its gravity pulled primordial gas into filaments, forming the first galaxies where those threads intersected. The illustrious and Eagle computer simulations run on supercomputers containing trillions of particles recreated this process with haunting precision. On their glowing screens, the universe looks like a living organism, strands of light weaving through the dark galaxies, blooming like coral along invisible spines. Those filaments are dark matter made visible through the light it shepherds. Without that guiding hand, there would be no structure at all, just a sea of thinly spread atoms cooling into silence. But as the universe aged, something unexpected began to happen. Instead of slowing under its own gravity, the expansion of space started to accelerate. Distant galaxies weren't just drifting away, they were fleeing faster and faster. In 1998, two independent teams studying type A supernovae, a class of stellar explosions so bright they can be seen across billions of light-years, discovered that the universe's expansion rate was increasing. It was as if a vast unseen energy were pushing everything outward. Scientists called it dark energy, though the name was more confession than explanation. If dark matter is the invisible hand that holds dark energy, is the invisible wind that drives. Its nature remains one of the greatest riddles in physics. It might be a property of space-time itself, a constant outward pressure predicted by Einstein's equations, but long dismissed as a mathematical quirk. Or it could be something entirely new, a dynamic field filling the universe and growing stronger as space expands. Whatever it is, it now dominates, making up nearly 70% of all that exists. Imagine it, most of the cosmos is not matter but a silent force woven into the geometry of existence. It doesn't glow, it doesn't attract it, simply urges everything apart. Galaxies that were once neighbours drift into solitude, their light stretching into redder tones as the space between them swells. The night sky looks still, but it's not. Even now, as you breathe, the distance between clusters of galaxies grows by millions of kilometres each day. Simulations like Illustrious and Eagle show this cosmic tension in motion. Early frames burst with filaments, webs of light bound tightly by dark matter. Later frames show those webs thinning, pulled wider by dark energy's relentless expansion. The clusters drift farther apart. The filaments stretch dim and begin to fray. It's a ballet both breathtaking and melancholy, the universe expanding into its own loneliness. And yet the beauty lies in the balance. Without dark matter, there would be no galaxies. Without dark energy, there would be no space for them to grow. The two forces are opposites, but their rivalry sustains everything we know. Matter gathers, energy disperses, gravity whispers come closer, expansion answers go beyond. Between them, existence finds its shape. Astrophysicists sometimes describe this balance as a conversation. Dark matter writes structure. Dark energy erases edges. One draws the cosmic map, the other stretches the page. Their interplay determines not only where galaxies form, but how long the universe will last. If dark matter ever wins, expansion will slow, and the cosmos might one day collapse back into itself. If dark energy wins, as the evidence suggests, it will continue accelerating until galaxies disappear beyond one another's horizons, leaving only isolated islands of starlight adrift in endless dark. In that far future, hundreds of billions of years from now, even the Milky Way's light will fade from distant skies. Future astronomers, if any remain, will see nothing beyond their own galaxy, and may never know there was once a universe beyond. It's a humbling truth we live in a fleeting window, when both darknesses balance, when the pull of matter and the push of energy create a cosmos rich in structure and light. We exist in the golden hour of the universe, when galaxies still dance, when night skies still shine. Perhaps that's why the knowledge feels both awe-inspiring and melancholy. We are built of atoms that make up only a sliver of what's real. The visible universe, the one we call home, is a bright foam atop an ocean of unseen forces. Every star we've ever wished upon, every nebula photographed by Hubble or Webb, is just 5% of the story. And yet that 5% is where consciousness happened, where hydrogen learned to think, where the universe for the briefest moment saw itself. Dark matter holds the galaxies together. Dark energy pulls them apart. Between them, light flickers for a little while, fragile and miraculous. That flicker is us. So when you gaze at the stars, remember their dance is not random. It's the rhythm of the universe negotiating between two infinities, one of gravity, one of emptiness. And somewhere in the middle, for a brief span of cosmic time, darkness and light found harmony. Everything that lives turns in a single direction. You can see it written in the double helix of DNA, that elegant staircase twisting always to the right. You can taste it in the molecules of life, the amino acids that bend left, the sugars that curl right. Even the smallest enzymes in your body are shaped by this bias, as though every atom remembers which way the universe first began to spin. This isn't coincidence, it's inheritance. The spin that shaped galaxies also shaped you. To understand how we must trace the spiral backward from the curl of a leaf to the swirl of a nebula. Chirality. The handedness of molecules is one of the strangest signatures of life. On Earth, nearly all living organisms use left-handed amino acids and right-handed sugars. Their mirror images exist, but life ignores them completely, as if the cosmos made a choice long before biology began. Why? The answer may lie among the stars. In the early 2000s, scientists studying meteorites found something astonishing: organic molecules older than the Earth itself, and they too carried the same imbalance, more left-handed amino acids than right. The Murchison meteorite in Australia, the Tagish Lake fragment in Canada, and even dust returned by NASA's Stardust mission from the comet Wild 2 all bore this subtle signature. Life's bias wasn't born on Earth. It fell from the sky. But how did space choose a side one clue comes from light, specifically circularly polarized starlight? When intense radiation from newborn stars passes through regions of dust and magnetic fields, the waves twist, turning in one direction more than the other. This polarized light, bathed across interstellar clouds, rich with prebiotic molecules, can destroy one molecular orientation faster than its mirror image. Over millions of years, the surviving molecules, though slightly more resistant to that cosmic light, accumulate a consistent handedness. In this way, the rotation of stars, galaxies, and even magnetic fields might have imprinted their spin on chemistry itself. Cosmic rotation became molecular rotation, a continuity of motion bridging the birth of worlds and the origin of life. You can see the echo of this ancestry in the laboratory. When chemists synthesize organic molecules from scratch, they typically produce equal mixtures of left and right forms. But when meteorite dust or polarized ultraviolet light is added to the mix, that perfect symmetry collapses. One side begins to dominate. The preference strengthens over time like a small tilt amplified through feedback, a chemical mirror of the universe's first broken symmetry. The Rosetta spacecraft's 2016 analysis of Comet 67P confirmed this on a cosmic scale. Its sensors detected simple organic molecules showing the same handed bias as those in living organisms. The implication is breathtaking. The building blocks of life were already spinning in their chosen direction long before Earth formed. The universe didn't just create life, it rehearsed it. Even the structure of DNA itself, that right-handed helix might trace back to those earliest influences. The twist isn't arbitrary, it affects how genetic information is stored, copied, and repaired. A left-handed helix would behave differently, perhaps even fatally so. It seems nature found one direction and never turned back. The same choice appears in proteins, which fold correctly only when built from left-handed amino acids. Reverse the spin and the machinery of life stops. From the microscopic to the cosmic, the preference persists. Hurricanes curve differently in each hemisphere because of Earth's rotation. Snail shells spiral predominantly one way. The galaxies themselves lean toward a faint statistical asymmetry, a preferred handedness revealed in surveys from the Sloan Digital Sky Survey and the Galaxy Zoo project. The bias is slight, yet real. More galaxies spiral left than right, or vice versa, depending on perspective. It's as if the universe remembers its own orientation, reflected in everything from starlight to DNA. This cascade of spin cosmic to chemical galactic to genetic is a chain of inheritance stretching across 13 billion years. The same asymmetry that nudged matter to triumph over antimatter, that shaped galaxies into spirals that determined the twist of starlight, may have guided the chirality of life. The lesson is simple, but profound motion scales. The same geometry that sculpts the cosmos whispers inside every cell. Your DNA isn't just a molecule, it's a continuation of the universe's rotation, a slow echo of cosmic spin translated into biology. Every heartbeat, every cell division, every neuron firing in your brain is a tiny repetition of that first turn. Life, then, is not separate from the universe's motion, it is its refinement. When we breathe, grow, and evolve, we are not defying cosmic rotation, we are expressing it in flesh and thought. Perhaps that's why spirals captivate us, the galaxies above the seashells, below the fingerprints on our skin. They are reminders that we were spun into being. The universe's great wheel keeps turning, and inside it life turns too. When you look at your hand, the curl of your fingers, the lines on your palm, you're seeing the echo of a pattern older than time. The same spin that stirred the stars shapes the molecules that let you reach for them. We are the motion made conscious, the universe's rotation slowed into awareness. The spin of life is not coincidence, it's continuity, the quiet inheritance of a turning cosmos that never truly stopped. In the beginning, before there were planets or oceans or even atoms gathered into dust, there was light, and that light was not neutral. It spun. Across the newborn universe, massive young stars blazed into being, flooding interstellar space with ultraviolet radiation. But their light did not stream evenly in all directions. Passing through clouds of magnetized dust, the waves twisted, taking on a subtle rotation, circular polarization. Some beams turned clockwise, others counterclockwise, like countless microscopic tornadoes racing through the void. That twist would become one of the quietest yet most decisive influences in the history of existence. Within those same interstellar clouds, chemistry was beginning its slow dance. Carbon, hydrogen, oxygen, and nitrogen, simple atoms born in ancient stars, were assembling into more complex molecules: formaldehyde, methane, alcohols, amino acids. These fragile structures floated in the cold, dark nebulae for millions of years, absorbing and re-emitting starlight. When circularly polarized light struck them, something extraordinary happened. One molecular hand absorbed the energy slightly differently than its mirror image. One side survived better, the other broke apart faster. It was the earliest election ever held, and the voters were photons. At NASA's Ames Research Center, scientists have spent decades trying to recreate that moment. In a vacuum chamber chilled to interstellar temperatures, they grew thin films of icy dust laden with organic molecules. Then they bathed the sample in circularly polarized ultraviolet light. When they analyzed the results, the surviving molecules showed a measurable imbalance, a tiny tilt toward one-handedness, just as life on Earth prefers. It was the first laboratory glimpse of cosmic bias written in chemistry. That same bias was later found in the relics of space itself. The Murchison meteorite, which fell in Australia in 1969, carried amino acids older than the solar system, and among them a clear preference for the left-handed form. Decades later, the Rosetta spacecraft orbiting the comet 67P Churyumov-Gerasimenko confirmed the presence of complex organic compounds exhibiting the same asymmetry. Even before Earth had cooled enough for oceans, the seeds of chirality were already drifting through space, carrying the faint imprint of polarized starlight. It seems the universe chose a side long before biology appeared to enforce it. The polarized light from early stars shaped by rotation magnetism and the scattering of cosmic dust passed on. A bias that cascaded through time. The twist of light became the twist of molecules, which became the twist of DNA, which became the spiral of life itself. Every right-handed helix in your cells, every left-handed amino acid in your muscles is a direct descendant of that ancient illumination. The same polarization that danced across nebulae billions of years ago now echoes in the geometry of your body. When light turned, it wrote direction into chemistry. When chemistry awakened, it wrote direction into life. It is humbling to imagine that the blueprint of our biology may have been drafted not by random chance, but by the subtle rotation of light in the arms of spinning galaxies. In a universe where nearly everything turns planets, stars, even space itself, it is fitting that light too would carry motion's signature. Astronomers using infrared polarimeters on telescopes such as Subaru and Sophia have observed regions like the Orion Nebula and the Rho-Ophiuchi cloud, where polarized ultraviolet radiation is strongest. In these nurseries of stars and molecules, the polarization reaches nearly 100%, a cosmic forge where light quite literally chooses. Within those clouds, amino acid precursors are forming today, their symmetry being broken anew, as though the universe keeps rehearsing the act of creation. Perhaps that is the ultimate unity of it all the same. Physics that twists galaxies also twists molecules, and the same photons that shape the cosmos shape us. Every ray of light carries a direction, a spin, a message from the universe's earliest dawn. When you step into sunlight, that ancient polarization still touches you. It brushes your skin, slips through your eyes, stirs the electrons in your neurons, the same kind of influence that once tilted the chemistry of prebiotic clouds toward life. You're in a quiet but literal sense illuminated from within by the memory of cosmic rotation. So the next time you look at a spiral galaxy or the curling tendril of a plant or the helix of a seashell, remember the curve is not accident, it's inheritance. The light that once chose a side in the cold of interstellar space continues its work inside every living cell. The universe writes its spin into everything it makes. In that sense, you're not merely alive, you are polarized starlight matter that learned to remember which way the cosmos turns. The universe, it turns out, has a preference, a tilt, a favorite hand. For centuries, scientists believed that nature was perfectly ambidextrous, that the laws of physics applied equally to left and right mirror and reflection. Drop a stone fire, a particle light a spark, the equations were supposed to work no matter how you flipped them. But in 1956, that illusion shattered, and the universe quietly revealed that even it plays favorites. The revelation began with a question no one expected would have an answer. Physicists Tsung-Dao Lee and Chen-Ning Yang wondered whether the weak force, the interaction responsible for radioactive decay, might violate parity, the symmetry between left and right. Until then, the assumption that nature was mirror-symmetric had been treated as sacred. No experiment had ever contradicted it, because no one had bothered to look. So they asked Chen-Xiong Wu, a brilliant experimentalist at Columbia University, to find out. In a bitterly cold laboratory in the winter of 1956, Wu and her team suspended cobalt-60 atoms inside a strong magnetic field and cooled them to near absolute zero, aligning their nuclear spins. As the cobalt nuclei decayed, they emitted electrons. If the universe were truly symmetric, the electrons should have flown out evenly in all directions, left or right, mirror and reflection. But that's not what happened. Wu's detectors found that the electrons overwhelmingly flew opposite the direction of the nuclear spin, as though nature itself preferred one orientation over the other. It was an unmistakable asymmetry, a crack in what had seemed the bedrock of physics. Parity once thought absolute was broken. The weak force, one of the four fundamental forces of the universe, was inherently left-handed. The discovery stunned the scientific world. Niels Bohr called it shocking. Richard Feynman called it one of the most important results in the history of physics. Li and Yang won the Nobel Prize the following year. Wu, whose meticulous work had made the discovery possible, was unjustly overlooked. Yet the truth she revealed remains one of the most profound in all of science. The universe itself distinguishes between left and right. You can see its signature everywhere. Neutrinos, those nearly massless ghosts streaming through your body by the trillion each second, all spin left-handedly. Their antimatter counterparts, antineutrinos, spin to the right. No law requires this. It simply is. The cosmos has an orientation, and we are built within it. From that subatomic preference arises an eerie harmony across scales. Storms on Earth curl differently in each hemisphere, their spirals shaped by the planet's rotation. Snail shells, tendrils, and even the swirls of human hair carry a bias subtle but consistent. Galaxies themselves seem to echo the same asymmetry. Surveys like Sloan Digital Sky Survey and Galaxy Zoo show a faint statistical lean toward one spiral direction over the other, as if the universe's own hand had written its motion across the stars. It's tempting to see coincidence, but physics whispers continuity. The weak force's violation of parity, the left-handedness of the quantum world, was the first sign that symmetry breaking is not an accident, but a rule. From that microscopic twist come all the spirals we see, from DNA's double helix to the hurricanes that spin across our oceans. The bias that began with neutrinos still turns within us. Even mathematics bends to this truth. When we write the equations of weak interaction, they are chiral. They treat left and right as fundamentally unequal. Mirror one and the other no longer fits. The universe, it seems, has chosen an orientation for its very laws. Some physicists wonder why. Was it a random choice frozen into the earliest moments after the Big Bang? Or does left-handedness serve some deeper purpose, a necessity for existence itself? If the universe had been perfectly ambidextrous, matter and antimatter might have annihilated completely, leaving nothing but radiation. The small tilt toward one direction may be the reason anything remains at all. When you trace this lineage, it becomes hard not to feel awe. A cobalt atom decaying in a cryogenic lab, a neutrino spinning through the void, a spiral galaxy rotating across billions of light years, all of them in essence are doing the same thing. They are following the universe's chosen hand. Look closely at your own. Its lines trace spirals and whirls that mirror hurricanes, shells, galaxies, and atoms. The fingerprint that identifies you is also a map of motion that began before time itself. You are built in the image of a universe that turns left. Perhaps that is what symmetry breaking truly means, not destruction of order, but the birth of identity. The cosmos could not be both things at once. It had to choose. And in that choice it found direction, structure, and life. From the quantum to the cosmic, everything we know, every breath, every orbit, every heartbeat is the echo of that primordial decision. The universe raised its left hand and creation began to spiral. And somewhere in that endless turning we learn to raise ours back. Every rhythm eventually slows. Every spin, no matter how graceful, grows heavy with time. The music of motion, the universal song that began with the Big Bang, has been decelerating ever since. You can see it in the skies above if you know where to look. Earth's own dance has been quietly losing tempo for billions of years. The moon, our eternal partner, pulls on our oceans, raising tides that drag against the planet's rotation. With every tide that rushes and retreats, a whisper of angular momentum slips away past like a gift to the moon. The exchange is invisible yet relentless. Earth's days grow longer by about 7 milliseconds each century, and the moon drifts farther from us roughly 4 centimeters every year. Laser reflectors left by Apollo astronauts still measure that retreat, a cosmic metronome ticking into the future. This friction between Earth and Moon is the slow heartbeat of loss, the sound of energy being shared, dissipated, rebalanced. The tides are not eternal waves, but the visible signature of time's drag. Elsewhere in the solar system, the same story repeats. Mercury, the innermost planet, spins in a strange rhythm, 3 rotations for every 2 orbits around the Sun. Once it may have spun freely, but over billions of years the Sun's gravity gripped it, twisting it into resonance. Now its rotation is locked in a steady beat, a compromise between motion and stillness. Every sunrise on Mercury lasts 88 Earth days, every sunset a quiet surrender to the Sun's pull. Venus tells an even more haunting tale. Its rotation is not just slow, it's reversed. The planet spins backward, completing 1 rotation every 243 Earth days slower than its year. Its clouds thick with acid and heat roll over a world that turns so gradually that day and night blend into a perpetual orange twilight. Some scientists think Venus once spun faster, perhaps even like Earth, before the weight of solar tides and atmospheric drag reversed it. Its stillness is a fossilized echo of motion, proof that even the most vibrant rhythms can be undone. And then there is Mars, a world that once turned with vigor. Ancient magnetic patterns frozen in its crust reveal that Mars once had a molten heart, churning and spinning, generating a magnetic field like Earth's. But its smaller size meant it cooled faster. Its core quieted, its field collapsed. Without that shield, solar winds stripped its atmosphere away, leaving behind a pale, exposed world. Mars still rotates one day. There is just 40 minutes longer than ours, but the rhythm feels hollow. A drum whose resonance has faded. The slowing isn't confined to planets. Stars lose spin as they age, shedding angular momentum through their stellar winds. Pulsars, neutron stars born from supernova explosions, begin life spinning hundreds of times per second, their beams sweeping space like cosmic lighthouses. Yet even these titans gradually lose their speed, their light pulses growing slower, softer further apart. Astronomers call it spin down, but it might as well be called aging. Even galaxies, the grandest dancers of all, are caught in the same decrescendo. Their rotations subtly change as they lose mass to intergalactic tides as stars die and gas dissipates. The Milky Way itself, now swirling elegantly through space, will one day merge with Andromeda. The collision will distort its structure, dispersing its ordered spin into a cloud of slow-moving stars. The great spiral will dissolve into an ellipsoid haze, the universe's equivalent of a final drawn-out note. All motion decays, energy redistributes, order unwinds. This is entropy, not as destruction, but as a slow diminuendo, a universal unspooling of rhythm into stillness. The laws of thermodynamics don't silence the cosmic music. They stretch it, lengthening each beat until it drifts into inaudibility. If you could hear it, the slowing of orbits, the drag of tides, the fading hum of stars, it would sound like a vast symphony winding down. The tempo drops imperceptibly at first, then steadily, like a record losing power. Galaxies waltz more languidly. Stars hum lower. Planets hesitate in their turns. The dance of creation becomes a meditation on exhaustion. And yet there is melancholy beauty in this slow fading. It means the universe remembers how to rest. Every slowing spin, every lost second of rotation is a form of grace, the cosmos easing its own heartbeat, after eons of relentless motion. Our planet's lengthening days are not failures of momentum, but signs of cosmic maturity. The same friction that steals seconds from Earth also stabilizes its tilt-softening climate extremes, giving life a steady rhythm. The moon's retreat preserves the tides and seasons we depend upon. Even in slowing motion, creates balance. Still, one can't help but feel the poignancy of it. Billions of years from now, the moon will drift so far that total eclipses will cease. Earth's spin will stretch until days last longer than our imaginations can hold. The music will keep slowing, measure by measure, as if time itself were falling asleep. Perhaps in the end, the universe is not a perpetual motion machine, but a song, one that began in a violent crescendo and now drifts ever so gradually towards silence. And maybe that silence will not be an ending, but a resting chord, a moment of stillness before the next verse begins. Galaxies, like living beings, are born restless. In their youth they spin quickly, their arms flung wide, bright with the fever of creation. The stars near their centres race at hundreds of kilometres per second. Clouds of gas swirl and collide, birthing new suns in flashes of light. Rotation is life's first breath on a cosmic scale, but nothing, not even a galaxy, can stay young forever. The universe, now almost 14 billion years old, carries the marks of wear. Ancient galaxies, though seen by the James Webb Space Telescope at the dawn of time, spin faster and tighter than their modern descendants. Their disks are compact, their light fierce. Over the eons that energy ebbs, collisions, mergers, and the invisible drag of dark matter act like friction in an unimaginably vast machine trading motion for structure, speed, for stability. Every galactic merger is both an ending and a renewal. When two spiral galaxies meet, their delicate disks are shredded by gravity's tides, their orbits tangled into chaos. Stars rarely collide directly, they are too far apart, but their motions are stirred, slowed, and blended into a new form. The graceful spirals flatten into an ellipsoid haze. The galaxy grows rounder, quieter. Its spin doesn't vanish. It disperses, converted into random motion, a slow ballet of billions of suns now moving to a softer rhythm. The Milky Way faces such a fate. In about 4 billion years, it will meet Andromeda head-on, their dark matter halos already brushing invisibly. At first, their spiral arms will tangle like ribbons in wind. Then, after hundreds of millions of years, they'll merge into one luminous oval, Milkomeda. Its stars no longer whirling in neat circles, but drifting in long, stately orbits around a shared heart. From the edge of that future world, the night sky will blaze with tens of thousands of nearby suns, brilliant and motionless to the eye. Yet beneath that serenity, an ancient spin will still be present, redistributed, rephrased. Astronomers call this process angular momentum transfer. It's the same principle that slows a skater's spin when she reaches out her arms. Galaxies too stretch with age, trading speed for reach. Dark matter halos absorb some of the momentum, stabilizing the structure. Black holes at their centers feed on the gas, and stars, funneled inward by the chaos and the energy they release, drives winds that further sap rotation. Every exchange preserves the total balance, but shifts the music's key. If you could watch the universe in time-lapse, the change would feel like watching a dancer age the quick, tight pirouettes of youth, giving way to slower, fuller movements of grace. Spin transforms, it never dies. It is merely handed from form to form, from star to gas, from orbit to halo, from ordered rotation to the random shimmer of motion. Perhaps that is what aging means on every scale, not stopping, but redistributing energy, finding new rhythms for the same eternal music. The cosmos does not mourn its slowing any more than autumn mourns summer. It only changes tempo. When you gaze up at the Milky Way's silver river, remember that its calm is deceptive. It is not still. It is simply older. Each star you see has already traded part of its motion to the dark matter that cradles it, to the spiral arms that stretch and fade, to the future merger that waits ahead. The galaxy is preparing slowly for its next form, and maybe so are we. Human lives mirror this same exchange speed for depth, energy, for perspective. We too learn to move more slowly but with more understanding. The hands that once spun wildly now reach outward, sharing momentum with others, shaping what comes after. The galaxies that grew tired are not failures of motion. They are its continuation in another key. The great spirals will merge, drift, fade, but their spin will persist, encoded in the orbits of new stars, in the invisible gravity of dark halos, in the quiet curve of the universe itself. Motion never truly ends. It only finds gentler ways to continue. In the end, the universe keeps only what it cannot forget: its motion. Even when the light of galaxies fades and the great spirals dissolve into silence, rotation endures, folded into the densest remnants of all. The stars, those ancient engines of fusion and spin, do not die quietly. When a massive one collapses, its core implodes with such force that protons and electrons merge into neutrons, forming an object barely 20 kilometers wide yet heavier than the Sun. A neutron star is what remains when matter can fall no further, a sphere so dense that a teaspoon of it would outweigh a mountain. And because angular momentum is sacred, its rotation, once spread across 1,000,000 kilometers of plasma, compresses into a blur. The newborn neutron star spins dozens, even hundreds of times each second. As it turns, its magnetic field whips around, with it sending beams of radiation sweeping through space like the beams of a cosmic lighthouse. Each time one of those beams brushes past Earth, we see a pulse of light. Astronomers call them pulsars, the ticking clocks of the universe. Some are so precise that they rival our best atomic timekeepers, their spins slowing by less than a microsecond per year. Even in Death Stars keep time with astonishing loyalty. But the music of collapse doesn't end there. When two neutron stars spiral together, their combined rotation tears space-time itself. In 2017, the LIGO and Virgo observatories caught the faint tremor of such a collision, a ripple in the fabric of reality traveling at the speed of light. For the first time, we heard gravity move. The event, named GW170817, announced itself as both sound and light, a gravitational wave followed by the flash of a kilonova, where gold and platinum were born from the fury of spin meeting spin. Each merger marks a kind of final choreography, the universe's most violent pas de deux. As neutron stars or black holes spiral inward, they shed energy as gravitational waves, the same way dancers lose breath. Each orbit shortens, each rotation quickens until both collapse into one. The waves they send outward are not sound, yet they carry rhythm, chirps, crescendos, decays. The detectors on Earth record these like the notes of a dying symphony, the last turns of stars echoing through space-time. Soon new instruments will join the listening. The space-based LISA mission, 3 satellites trailing the Earth in a triangular formation millions of kilometers wide, will open its ears to lower frequencies, catching the slow waltz of supermassive black holes colliding at the hearts of galaxies. These behemoths, spinning thousands of times slower than pulsars yet dragging entire worlds in their grasp, will reveal a deeper register of the cosmic rhythm, gravity itself breathing. Black holes are the ultimate repositories of rotation. When a star collapses beyond the neutron threshold, it folds its spin into the curvature of space-time, creating a vortex from which not even light can escape. Around it, everything whirls: the gas, the photons, even time itself. Astronomers describe this geometry with 2 numbers: mass and angular momentum. Everything else, as physicist John Wheeler said, is hairless, erased by gravity's perfection. Yet even the black holes are not eternal. Stephen Hawking showed that quantum mechanics gives them a faint ghostly glow, Hawking radiation. Over unimaginable timescales, they radiate away, mass shrinking and slowing until their final spin evaporates into nothing. What was once the fiercest expression of rotation becomes the gentlest release, a final exhalation of angular momentum into the vacuum. Picture it: the last black holes of the universe, billions of trillions of years from now, spinning ever more slowly in a sky gone cold. Their event horizons, once sharp, blur and fade. The gravitational waves have long since quieted. The stars are gone. Even protons have decayed into dust. Only the memory of motion remains rippling faintly in the sea of space-time, a signature without a source. And yet that faint hum is enough. It means the universe never truly stops. Each rotation, whether of an atom, a planet, a galaxy, or a black hole, feeds into the next. Energy changes form, but motion persists. Even as the music thins into silence, its last notes drift outward. imperceptible but real, carrying the rhythm of creation into eternity. Perhaps in that final moment the universe will resemble the slowing of a great record, the tone deepening, the melody stretching until it becomes one unbroken note. And when that note finally fades, it will not be death, but completion, the last turn of the stars resolving into stillness. Somewhere in that stillness the last spins unwind, dissolving into the dark, and perhaps, just perhaps, the universe will listen to its own silence and remember what it once sounded like. When all the fires burn out and all the stars go dark, one thing will remain motion, not as speed or spin, but as memory. The universe began in motion and will end in it, though by then it will be motion of a kind we can scarcely imagine. Every rotation, every orbit, every dance of energy and gravity leaves behind a trace, a curvature, a rhythm, a whisper written into space-time itself. Angular momentum cannot die. It can only diffuse its once vivid turns, stretched across the expanding dark like the fading echo of a bell. By the time the last star flickers out, the cosmos will already be deep in its twilight. The galaxies will have drifted apart beyond one another's horizons, carried by the expansion of space, until even light can no longer bridge the distance between them. Within each isolated island of matter, stars will exhaust their fuel, fusing their last hydrogen into iron before collapsing into white dwarfs, neutron stars, and black holes. These remnants will spin on, slowly losing energy to gravitational waves and Hawking radiation. And when even the black holes evaporate, what remains will be a thin cold haze of particles, photons, and geometry, a universe emptied of warmth, but still shaped by the turning that once was. This is the heat death, not fire, but perfect stillness. Every temperature equal, every gradient dissolved, every possibility of change exhausted. Yet even in that final stillness, angular momentum endures not as motion we can see, but as curvature in the fabric of space, the imprint of all the turns that ever happened. The universe will no longer move, but it will remember that it once did. Physicists sometimes speak of this future in the language of thermodynamics, of entropy and equilibrium. But perhaps it is better imagined as music stretched beyond recognition. Each rotation, each orbit, each flicker of energy contributes a note to the cosmic symphony. As time stretches, those notes slow and lengthen, merging into one continuous tone until what was once a melody becomes a hum, and what was once a hum becomes silence. But silence too has resonance, it carries the memory of sound. Somewhere in that silence, the geometry of motion remains the faint curving of space-time, the residual swirl of quantum fields, the subtle asymmetry that began with the first broken symmetry. Motion becomes form, energy becomes space, time itself becomes a museum of movement. If you could drift through that far-future universe long after stars and matter and light have gone, you might still feel it, the ghost of rotation, not in things, but in the way distances curve and the way emptiness feels slightly tilted. Every atom that ever spun, every galaxy that ever turned contributes to that invisible architecture. The universe will not forget. It's a strange comfort, this endurance of motion's memory. It means that nothing truly ends. It only changes expression. The rotations that once made galaxies and lives now shape the stillness that follows. Even when entropy has claimed every spark of heat, the scaffolding built by motion will remain quiet and eternal, like the score of a song no longer played but still written in the notes. And perhaps, if there is something beyond some rebirth, some fluctuation in the void that sparks a new beginning, it will arise from that memory, from the faint lingering geometry of spin that never left, from the echo of motion whispering to itself, I once was. In that sense, heat death is not oblivion, but rest. The universe will not vanish. It will sleep wrapped in the memory of everything that ever moved, every swirl of a nebula, every orbit of a planet, every heartbeat that ever synchronized with the Earth's rotation, each becomes part of that memory. Motion stretched so thin it becomes space itself, rhythm slowed until it merges with time. The end then is not the extinguishing of motion, but its transformation into eternity. The universe will remember quietly the way it once spun, and in that remembrance motion will finally become peace. The universe will not end in fire, but in silence. Long after the last stars have burned out and the galaxies have dissolved into faint ghosts of light, even the smallest particles will begin to fade. Protons, the sturdy bricks of atoms, are not eternal. They are believed to decay, though with lifespans so vast that a trillion years pass before a single one vanishes. Yet time is patient. One by one they will unravel, releasing wisps of energy into the dark. Matter as we know it will cease to exist. By then, black holes, the final citadels of motion, will be all that remain. They will spin for eons, their rotations slowing as they radiate away their mass in the faint glow Stephen Hawking predicted. Over unimaginable timescales, they will shrink-brighten for an instant, and then disappear, leaving behind only a shiver in space-time, a tiny wrinkle, where something once turned. What will remain after even the black holes die is a universe of pure geometry, no stars, no matter, no warmth. Only stray photons thinly scattered across an ever-expanding void. Their wavelengths stretch so long, they can no longer interact with anything. They will drift endlessly like echoes of light too tired to fade completely. The cosmos will be vast, dark, and almost perfectly still, and yet not empty. Even in this silence, the memory of motion persists. Angular momentum, so long conserved, so long exchanged, will not vanish, but become a kind of imprint on reality itself. Every turn that ever was will have left a trace written into the curvature of space-time. The universe's geometry will remember where things once moved the way a frozen lake remembers the waves that rippled before it froze. Physicists call this the conservation of information, but it is also a kind of poetry. Spin motion energy, none can be destroyed, only transformed. When all else has gone, these will survive as equations as the invisible architecture of what once lived and moved. Even in stillness, the mathematics of motion endures. Perhaps in that far epoch, the age of silence, the universe will resemble a page after the ink has dried. The letters have stopped moving, the story has ended, but the shapes remain. Space will still carry the faint curvatures, where galaxies once danced, where black holes once spun, where time itself once flowed like a river. No observer will remain to see it. No eyes, no instruments, no minds. The last photons will drift endlessly, crossing distances so immense they will never meet anything again. Time will lose its meaning. Without motion there can be no change, and yet the memory of motion will still shape the void. If you could somehow step into that silence, billions of trillions of years beyond comprehension, you would not see darkness as we understand it. You would see transparency and infinite clarity in which nothing moves because every possible motion has already happened. The universe will be the perfect archive of its own story, the still sculpture of everything that ever turned. And in that sculpture motion itself will have become our pure form stripped of energy distilled into geometry. The great rotations of galaxies, the spins of atoms, the orbits of worlds, all will persist as gentle warps in space-time frozen waves in a cosmic sea that can never stir again. This is not tragedy but completion. The symphony that began with the furious drumming of the Big Bang will end with a single unbroken note, a silence so deep it contains every sound that came before. In that silence the universe will finally rest. The memory of motion will be its monument, its legacy, its final breath. And though no one will be left to hear it, the equations will still hum beneath the stillness saying only I turned. I existed. I remember. Every human being is built from motion older than light. The atoms that make up your body, hydrogen, carbon, oxygen, iron, were all born from rotation stars spinning, collapsing, exploding. Galaxies wheeling through space, particles turning in invisible fields. Every one of them still spins. The angular momentum that once shaped the first clouds of the cosmos hums quietly inside you. You're not separate from the universe's motion. You are its continuation. Deep within each atom, electrons circle the nucleus in quantum orbits defined not by position, but by spin, tiny magnetic twirls that never stop. The protons and neutrons inside that nucleus also spin the relics of ancient collisions when quarks froze into matter. Even when you're perfectly still, billions of these microscopic rotations churn inside you a quiet storm of inherited momentum. The universe has been conserving its motion since the beginning, passing it down like an heirloom. What once stirred galaxies now stirs your blood. What once turned in the heart of a star now turns in the neurons of your mind. You move because the cosmos moves through you, and in that movement lies awareness. Somewhere along the long unfolding of spin motion began to reflect on itself. From rotating atoms came molecules, from molecules cells, from cells minds. At some point the turning became self-aware. The same angular momentum that drives planets and stars found a new expression in the human brain. Neural waves, oscillations, rhythms of thought. Consciousness in this light is not something separate from physics, but a new phase of motion, the universe thinking about its own rotation. When you remember, when you imagine, when you dream, the electrical activity inside your brain pulses in rhythms measured in Hertz cycles per second. Thought itself is frequency spin translated into experience. Every idea is a wave, every emotion a vibration in the electric seas of your mind. You are the cosmos performing its own harmonics. The physicist Erwin Schrödinger once wrote, "What we observe as material bodies and forces are nothing but shapes and variations in the structure of space. If that's true, then we are shapes of motion, temporary eddies, in the larger flow. Our bodies, our consciousness, our loves and losses are not interruptions of the universe's dance, but movements within it." You can feel this continuity if you pay attention. The pulse in your wrist beats with the Earth's rotation. Your circadian rhythm mirrors the turning of the planet. The iron in your blood aligns faintly with magnetic fields born from Earth's spinning core. Even your breath follows cycles of expansion and contraction, like the universe itself. And perhaps in that recognition, something deeper stirs a memory not of events, but of belonging. The awareness that the motion inside you and the motion beyond you are the same thing, separated only by scale. The atoms that spin in your body once turned in the arms of a star. The starlight that warms your skin carries the signature of the same angular momentum that shaped the galaxies. You are the universe folded inward, remembering itself. When you close your eyes, you can almost feel it. The hum of 1 billion invisible rotations, the flicker of electrons, the slow turning of the Earth, the spiral of the Milky Way, all moving in the same direction. Consciousness is that harmony made visible a moment when matter pauses just long enough to notice its own rhythm. Perhaps that's what memory truly is, not a record of the past, but the persistence of motion within us. Every heartbeat, every thought, every breath is the universe's way of saying, "I am still turning." Physics calls it conservation. Poetry calls it remembrance. But they mean the same thing: nothing is lost. Motion becomes life, life becomes awareness, and awareness becomes the mirror in which the cosmos sees itself. You are that mirror. The same angular momentum that began at the dawn of time now lives behind your eyes, asking the oldest question, "What am I?" The answer is simple, though it takes a universe to say it. You are made of the memory of motion starlight that learned to think gravity, that learned to feel the great turning of the cosmos slowed into the stillness of a human soul. The universe remembers through you. And as long as you exist, even for a moment, motion has not been forgotten. Everything that moves, shines, or thinks is a form of rotation. Light magnetism and consciousness are not separate miracles, they are different dialects of the same language of motion. The photon, the electron, the neuron, and the galaxy all speak it fluently. A photon, the smallest packet of light, carries spin an intrinsic twist that gives it polarization. Every beam of light is in a sense a tiny spinning wave, its oscillation defining the direction of its electric and magnetic fields. When light passes through the cosmos, its polarization can change, tilted by magnetic fields, warped by gravity, or stretched by time itself. The polarization patterns in the cosmic microwave background, the universe's oldest light, are fossils of that first spin. They show us that from its earliest breath the cosmos was turning. Now imagine the magnetism that shapes our world. The compass in your hand points north, because electrons within the atoms of iron have aligned their spins, creating a magnetic field. Deep within Earth, molten iron rotates and churns, generating a vast dynamo that extends thousands of kilometers into space. This field shields us from solar radiation and connects us invisibly to the sun, whose own spinning plasma creates a solar wind that flows past every planet, binding the solar system in a rhythm of charged motion. That same magnetism whispers in your brain. When billions of neurons fire together, the faint electrical activity generates magnetic fields so delicate that only the most sensitive instruments can detect them. They are measured in femtoteslas, trillions of times weaker than the Earth's field, and yet they carry thought. Your dreams, your memories, your sense of self are built from spinning ions and oscillating electrons. Your brain, in its quiet complexity, mirrors the geometry of the cosmos. The waves that ripple across your cortex follow the same mathematical forms as the waves that ripple through interstellar plasma. NASA physicists once described frame dragging the way a spinning planet twists space-time around it as the universe's way of remembering motion. Perhaps consciousness is the same, but on a smaller scale. Every magnetic pulse, every neural oscillation, every thought that circles back upon itself is a kind of frame dragging within the mind, a local distortion in the geometry of awareness. If you could step outside your body and see yourself through the eyes of physics, you would be luminous with motion. Every particle, every molecule, every neuron a tiny gyroscope. The photons that illuminate your surroundings are spinning. The atoms that compose you are spinning. The planet beneath you spins, and all of it is carried within the larger whirl of the galaxy. There is no stillness anywhere, only motion so synchronized that it feels like peace. Einstein once said that energy and matter are interchangeable expressions of the same thing. We might say the same of thought and rotation. Consciousness is what happens when motion becomes recursive, when energy curves inward and reflects upon itself. The universe is not merely expanding, it is learning. Every polarized photon, every neural rhythm, every planetary spin adds another line to the same cosmic sentence, I am still turning. In this sense, memory, magnetism, and light are all forms of the same continuity. A photon remembers the magnetic field it passed through by the angle of its polarization. A brain remembers an emotion by the pattern of its electrical spin. Space-time remembers every rotation by the subtle curvature it leaves behind. Memory is not stored in time, it is time, the persistence of motion written into the structure of reality. So when you think, when you imagine, when you love, the act itself is cosmic. The photons leaving your eyes carry your gaze as polarized light. The magnetic pulses in your brain echo the rotation of stars. The heartbeat that steadies your breath keeps time with Earth's turn. You're not a spectator of the universe's dance, you're one of its dancers. Each thought is a step, each breath a turn. The same spin that set galaxies in motion now moves through the quiet circuits of your mind. Somewhere in this symmetry, the universe completes its circle. From quantum spin to cosmic rotation, from light to thought motion, has become awareness, and awareness in turn is motion remembering itself. Take a slow breath. Feel your pulse. The rhythm you sense is not merely biological, it is cosmological. You are the space between atoms and stars, the pause between beats of eternity, the place where the universe has stopped just long enough to realize it exists. The universe remembers itself through light, through magnetism, through you, and that memory keeps it alive. In the end, everything returns to calm. Not silence in the sense of absence, but silence as completion, the moment when every rotation, every orbit, every vibration resolves into harmony. The universe has turned for nearly 14 billion years, and so have we. Stars have risen and faded, galaxies have collided and drifted apart, and through it all one rhythm has endured motion, giving birth to time and time giving meaning to motion. You are still part of that rhythm. Right now as you breathe, the earth turns beneath you, slow, patient, steady. Your lungs expand in tempo with the planet's spin. Your pulse matches the rotation of its molten heart. Every breath you take is synchronized with the quiet machinery of the cosmos. When you close your eyes, you can feel it, the gentle gravity holding you to this turning world, the magnetic hum beneath your feet, the endless orbit of moon and sun. You're not apart from this motion. You're its witness and its continuation. The same angular momentum that shaped galaxies now moves softly through your blood. Every heartbeat is the echo of creation's first spin. Even when the last stars fade and time stretches into stillness, that echo will remain. Somewhere in the geometry of space, the memory of every rotation will be written. The whisper of light through dark, the curve of gravity around mass, the faint pulse of the universe's own heart. And within that quiet record, our small movements, our lives, our loves, our thoughts will remain folded into the larger motion, indistinguishable yet essential. So breathe slowly. Let the air enter like the tide and leave like the wind. The calm you feel is not the end of motion. It is motion perfectly balanced. The same serenity that holds the planets in orbit now holds you right here in this moment. If these quiet journeys have brought you peace, I thank you deeply for traveling with me through them. Each time you listen, each gentle, like each comment shared across distance, is another orbit, a small act that keeps this constellation of curious hearts turning together. You're part of the same cosmic rhythm that began long before us, and will continue long after. Tonight, as the world drifts beneath the stars, know that you are spinning in harmony with everything that ever was. Rest inside that motion. Trust its stillness. Feel the gravity of belonging. May the universe turn softly around you, and may you find your place in its final calm. Good night, and thank you for being part of the motion that never ends.